Hey, how's everybody doing? Get this show on the road. Let me check the volume levels here. I'm not blowing everybody's ears out. And let's give it a try. A bit loud, I guess. Maybe just a touch lower. Out there. How's that? So hey, how's everybody doing? Pilsner, I'm sorry about that. I don't know why Twitch didn't send them out. I mean, it did go live, so I don't know why. Hey V Maui, how are you doing? Guess I didn't leave enough time for Twitch to send it out or something. I don't know. Alrighty. As you can see, it does do terrain now. There's apparently a peak of 9,100 feet somewhere in there. Probably one of the corners here. Oh, probably there. Alrighty. Time to stop messing about. And what I actually wanted to check here, right there it is. RNAV 2, RNAV 11. It is an EGNOS LPB approach. How does this one go? Bring up you, and I want to go from Uraso. Or that's gotten that, rid of that. And I'm gonna go heading correct to there, or turn there. Discontinuity. Okay, Intel effects. And I can give speed control back to B now. So as I'm currently pointing, there's pretty much no terrain there, so this is what I've been working on. Futile terrain avoidance, yes sir. Alright, there was one more piece it needs to print out when the terrain range does not agree with your display range. Needs to let you know about that. Good stuff. Do I have alignment on my INSs since I've just restarted the simulator? Pretty good. Close enough anyway. Are there speed constraints on here? No, there are not. Only in the missed approach. So we'll be responsible for our own speed control here. The ever-present X-Plane oil rig in the Mediterranean currently. Now it's just direct. Enter LNAV. Good stuff. Hey Pilot Pro, how are you doing? How about some hot air balloons in the middle of the ocean, in the middle of the sea? Absolutely. Crash into anything yet? Not yet, Pancake. Just barely started the stream here. Give me some time to shine. I'm I'm basically trying to test here, make sure it doesn't spaz out on some common approaches, especially in approaches with terrain. I don't want it to generate spurious alerts when you're just, you know, on a routine approach. Peaks 0, because within 5 miles there's nothing but water. So it basically says no significant terrain. But if I zoom out, you should start seeing something on there, and if I keep zooming out, I'm gonna get to see a lot more. Always got terrain alerts coming from Tromsø to Tromsø from the north. That's a good thing. We might try that, yeah. So on the base leg here, I'm going to slow down to like 210 or something to get some flaps rolling. And then it's 2,600 for final. So start to slow down. You can expect to zoom way out and not have issues with XP not loading terrain tiles. Amazing, eh? It's almost like a don't use X-Planes terrain tile whatever. This is 200 miles away. So you're basically seeing the coast of Croatia here, and Italy is over here to the back. This would be probably Greece at this point. Or actually, this would be Macedonia. Greece would be probably a little bit further down. Okay, message. It wants to check alt cell, so that means I'm within a minute of top of descent here. So roll you on down. 2,600 feet is the final approach altitude. Or platform is what they call it sometimes. Final platform altitude. Minimums on that procedure are for LPV 810. So refs. Just roll them on down. There we go. Arrow approach. Sure, that will do. That's something we can do. So let's get initial stage of flaps going here. Slow down to 180. Terrain alerts. How do bus drivers fly into Barrow? They use special buses with different terrain alerting. They might have just inhibited terrain awareness alerting. So it does have this. So the Jitwiz or TAWS or however you want to call it has a truckload of functionality in it, and I simulate all of it. Well, apparently still gotta do obstacles, but other than that, we're essentially all there. So Peak's functionality here was kind of a fun one to implement. It is done like most of everything else with some effectively GPU compute. 2,600 feet, so we'll go ahead and arm VGP. There we go. And we got angular mode, good stuff. It's no longer going to stop at the final approach altitude there and go around altitude here is 4,000, so let's roll it up there. Obstacles was my next question. Do obstacles show up on the SBS like they do on the TBM? Actually, they don't. No. On the TBM, it's all an integrated system, so Garmin did implement them in a consistent manner. The Challenger's SVS isn't that sophisticated. It doesn't do obstacle display separately. I believe they can inhibit it if they are allowed to. Yeah. And if it would be a detriment to safety, you know, why not inhibit it? Of course, they have procedures. 2500, yes. And you can see it's pointing right at the touchdown zone there. So, what are you unhappy about? Check SBAS service provider. Ah, right, that's the thing I gotta fix. SBAS EGNOS check. Check laterally as well. Good stuff. Screen freezing? Hopefully not. Let's fetch our latest weights here. And I'm gonna go slow down to final approach speed here, 131. And final stage of flaps here. Go away. I am configuring a little bit late here, but whatever. We're not gonna be landing anyway. Or will we? Might just go around.
1,000.
1,000 is noted.
Approaching minimums. 500. Minimums.
Good stuff. That was a bit of a hop there. Disconnect you.
Take flaps.
Yes.
Take flaps.
There we go. Positive right gear's coming up. We're already in LNAV here, so no need to already above target speed, so let's go ahead and accelerate. Hey heli pilot, how are you doing? $1,000 to go. NV Alt S cap. Good stuff. Oh right, I should probably put in the ATS again. Anyway, more importantly, what I wanted to check here is mess around with the terrain system. So, all you terrain awareness system aficionados will know that. Well, and I just lost my mic stand here. Got a little bit unstuck. Stand by. Yeah, stay. Don't fall off. Again. It's just a suction mount, which is not really kind of meant for what I'm using it for, so... Anyway, we've got plenty of time here. So, what I wanted to talk about, you know... Or question my autopilot doesn't follow.
2500.
So, all you aficionados for terrain systems will know that it has many different ways of functioning. Not all of which, well, very few of which actually involve any kind of database. So, quick recap for all you guys out there. So the terrain awareness system on the Challenger is made by Honeywell. It's the Honeywell EGPWS, the Mark 8 specifically, and yes, it is called the generic term. When I say TOS and EGPWS or GPWS, it's the same thing. It's just GPWS and EGPWS are commercial terms. They're basically product names for Honeywell, whereas TOS is sort of the generic terrain awareness whatever kind of system. So for example, Garmin has their own. It's called GTSA 20. That is a TOS. It's not a GPWS, because GPWS is a product name. But whenever I'm referring to one or the other, they're the same thing in this case. So if you know your history, and do let me know if you don't want me to ramble on about this. You know, do you know your history? Terrain awareness came. Check position. What are we unhappy about? Okay. Terrain awareness came in multiple. Essentially, well, terrain awareness initially came just by way of the. Well, Honeywell just called it GPWS, right? So it was essentially a kind of system that did not rely on any kind of database functionality. I believe it's either from the late 70s or early 80s. And that system, crucially, relies completely on aircraft sensors, primary aircraft sensors, and primarily the radio altimeter. And then secondarily, you know, things like your barometric altimeter, vertical speed indicator, that kind of stuff. But it does not require any kind of database. And so what Honeywell calls those are modes. Apparently you can buy an EGPWS for $6,000. Ah, cheap. You don't want to see the support contract for it though. So if I bring this up there, you'll be able to see that the thing has what they call modes. Now these are traditional GPWS modes. I'm going to just put the aircraft here in altitude hold, and just for quick sees, we're going to go into index, hold, new hold, present position, execute, and just wait here until I get my, stop flapping my face here. So Honeywell, so this was the original GPWS modes. Currently there are 7. Now those 6 modes, 90-day warranty apparently. Wow. Awesome. So there are 6 modes. 7th one is for reactive wind shear. We have that one as well. And all of these, crucially, all of these rely simply on aircraft configuration status, radio altimeter, barometric altimeter, vertical speed, that kind of stuff, but nothing more. It doesn't require GPS. It doesn't require terrain data. It doesn't require anything like that. So those are your, let's say, legacy modes. They're still there. The GPWS still does operate them, but they can be partially or completely overridden by a separate system or a separate set of functions, which if we go here, let's see, do we have like a nice index page? Operational procedure, system description, whatever. But they can be overridden by these. So let's say terrain clearance floor, runway field clearance floor, terrain alerting and display. It's primarily this guy. So this is the guy you know as on day 91. So this is the guy you know as you know, GPWS terrain. So when we go to page 29, it'll tell us that the GPWS uses a terrain database internally to look ahead for various conditions. So it basically looks down to a certain, essentially extrapolates the aircraft's paths down if it's descending. If it isn't, then it basically just looks ahead. And then there's a climb path up ahead further out in case you're, you know, about to run into a case where you would not be able to climb or you had to have kind of a marginal performance kind of a scenario. So it basically, this is what you use, this is what you inhibit TAD, or terrain alerting and display, sometimes called TAAD. This is what you inhibit when you go into here and you hit this button. This is your look ahead and look up terrain avoidance using the database. And also the database display here is what you see, what the TAAD system uses. This button here notably does not inhibit anything having to do with any of these modes. So these modes remain essentially always on, except for certain modifiers. So when you want to do, let's say, when you want to avoid the mode 5 glide slope alerts, you push that button. If you want to basically tell the GPWS that, hey, don't look at my flaps position, just consider them to be always in the landing config, or gear to always be in the landing config, then you push these buttons. But other than that, you can't actually disable a GPWS. You can disable the enhanced terrain function look ahead features, but you can't inhibit the basic modes. So these guys are essentially always on. So let's have a little bit of fun with the terrain system. And we can talk about each of these modes and what they do and how they work and all that good stuff. I just gotta come down a little bit closer to some terrain. So this is what they call mode 6, advisory callouts. What you just heard, always pull the breaker. I mean, yeah, that will very much inhibit it. So it's up here. Strangely enough, since it's a third-party piece of avionics, the aircraft does not power it via the DC buses. Actually, the terrain awareness, the GPWS or TOS system, sits on an AC bus. If I do that, you'll see no more terrain. And if I let it reboot again, there we go. And we're back in business. So let's play around a little bit with the terrain functionality. Let's say I'm completely oblivious here and I'm just driving about, looking at my cute little circles and I'm peeing in the sky. I'm not looking ahead. So there are mode floors and inhibits in place to try and avoid annoying you, but let's see what happens when I'm driving towards terrain. And this is the enhanced features. In fact, screw that. We're gonna go with just the bare GPWS functionality with just a radio altimeter. You'll notice I'm still driving at terrain, even though, or rather, I'm not getting any alerts or anything. I'm just driving at the terrain here, and nothing is happening. That's because I've inhibited the terrain advanced look ahead features. It's still gonna paint terrain if I want, if I tell it to.
2500.
But these callouts, these mode-based callouts, are simply terrain-based, or rather radio altimeter based. It has no clue that I'm actually about to drive into some mountains here. At this point, it would be screaming at me. But you'll notice if I keep going at it, so it does recognize, because of the fact that my radio altimeter is decreasing like crazy, we triggered what they call mode 2A. That is rapidly rising terrain underneath the aircraft approaching your altitude. Now, it was recognized fairly early on that these kinds of warnings, although useful, are not necessarily sufficiently. You could always pull the brake. Yeah, okay. So they've recognized that they don't actually give you enough warning ahead of time, right? Just roll away that altitude selector. It's going to stay saying it's going to stay illuminated here ground proximity for 40 seconds after the encounter unless I climb an extra 300 feet. That's how mode 2 alerts work. So if I do get a mode 2 alert, I need to either climb or just wait it out. Then you've got mode 1 alerts, which are descent based. So if I'm descending at an excessive rate, and these are dependent upon the rate of descent versus radio altimeter value. So 2,500 feet.
Sink rate.
It's gonna keep it there.
Sink rate. Pull up. Pull up. Pull up. Pull up. Too low. Terrain. Too low. Terrain. Too low. Terrain.
And if I go and fly just above this terrain here, the rising terrain is going to trigger a mode 2 alert. Even if I'm sufficiently high to clear the terrain, since this is radio altimeter based, it has no clue. Yeah, that was some weirdness. I don't know why.
Pull up.
This is mode 2
Pull up.
here.
Pull up. Pull up. Too low. Terrain. Too low. Terrain. Too low. Terrain.
These are all radio altimeter based.
Pull up. Pull up. Pull up. Too low. Terrain. 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 Pull up. Pull up. Too low. Terrain.
Yeah. All right, so this is enough radio altimeter trickery, I'd say, for now. We can go ahead and let's see, where is my airport? Now we're good.
Pull up. Pull up.
Let's just go ahead and go direct to. We can select an approach here. RNAV 29er via vectors. Yes, sure. Good stuff. Actually, screw that. Not RNAV 29er. They're straight in. Anything straight in. VOR alpha. There's going to be a bug in here for visual approach functionality, so I'm not going to try that out for now. I don't want to interrupt my little escapades I was saying. Hold at vectors. I was paying half attention and I heard hold at vectors. Well, at least the toss system is fun to test. Yeah, so let's see. Actually, I can test that without coming down to the airport. So let's just go like this. I can show you mode 3. So mode 3 is an altitude loss after takeoff or low-level go-around. So I can actually trigger that by going below 230 feet radio and then inducing a climb outside of takeoff config or landing config. Let's just get some speed brake out.
Sink rate. Sink rate.
Or sync rate, whatever.
Pull up. Pull up. Pull up. Pull up. Pull up. Pull up. Pull up.
Okay. me just get some drink here. Thank you. With ice cubes in it as well. Cool stuff.
Too low. Terrain. 500.
So this is a gear warning here yelling at me as well. It's actually not coming from the TOS, it's coming from the data concentrator units from the ICAS system. So if we come down below...
Too low. Gear. Sink rate.
what are you yelling about? Okay, flight spoilers deploy, I know.
50. 40.
Okay, and now if I do a climb, it should think that we have done a low-level go-around. Ice green tea, not quite. So now if we do this, if I do an altitude loss,
Don't sink.
hear this,
Sink.
don't sink is a mode 3 alert. Basically thinking that you've done a go-around and you haven't yet cleared the minimum altitude height for that, which is 1,500 feet. So if I now level off and start sinking again,
Too low. Terrain.
here we go, and again go up. And if I go and level off before 1,500 feet, or just about,
Don't sink.
yeah, there we go.
Don't sink.
And it's going to keep yelling at me for every 20% of loss of height.
Don't sink. Too low. Terrain.
And this is mode, it's actually the TCF functionality.
Too low. Terrain. Too low. Terrain. Too low. Terrain.
Anyway, so that was mode 3.
Terrain.
It's not ice green tea,
Terrain.
it's just a kind of Coke. Just a kind of soda. Cool. So, theoretically, okay, now we've cleared the mode 3 altitude threshold, so I can now descend fine. Okay, now it's happy. So no more don't sink alerts. Good stuff. So mode 4 is a little bit complicated. It has to do with minimum radio heights with respect to aircraft configuration. So when I was to, say for instance, descend early with no gear down, it would start yelling at me there was no too low terrain or too low flaps or too low gear. So that's what those were. If I go ahead and dump it down here, and they are based on speed as well. So currently I am flying way too fast for the low speed section of the alerts to come and trigger. So currently I am, if I go down now below a certain speed or below a certain radio altimeter, radio
1,000. Sink rate. Too low. Terrain.
too low terrain, so that was mode 4.
Too low. Terrain.
But if I go and drop some flaps,
Too low. Terrain.
we know I didn't want to drop gear.
Too low. Terrain. Too low. Terrain. Too low. Terrain. Too low. Terrain.
Let's just keep
Too
it
low.
there.
Terrain. Too low.
Start rolling
terrain.
those flaps, roll flaps,
low,
roll
terrain.
flaps.
Too low. Terrain. Too low. Terrain. Too low. Terrain. Too low. Terrain.
It might actually be TCF or RFCF that's yelling at me here.
Too low. Terrain. Too low. Terrain. Too low. Terrain.
Yeah. Let's see, if I come close to the runway, it should shut up. TCF.
Too low. Terrain. 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 Too low. Approaching minimums. Too low. Terrain. Pull up. Pull up.
Okay, this
Too
is
low. Terrain. Too low.
2
terrain.
again.
Too low. Terrain. Too low. Terrain.
Why aren't you triggering gear protection?
Too low. Terrain. Too low. Terrain. Too low. Terrain. Too low. Terrain.
Let's see, what's
Too low.
mode
Terrain.
4, trigger 4. Too low gear. There should be a gear warning as well. Too low terrain. Too low gear. Less than 178 knots. And the too low gear warning section is 500 feet radio. So I'm gonna go and so we've got terrain disabled here. Quickly
Bank angle.
bank over.
Bank
Yeah, that's
angle,
mode
bank angle.
6, I think.
Bank angle. Bank angle.
Yes. I know.
Approaching minimums. Too low. Terrain. Too low. Terrain. Too low. Terrain. Pull up. Pull up. Too low. Terrain. 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 Too low. Terrain.
Okay,
Too low.
who's generating this? I want to know. 'Cause I want to know exactly what's yelling at me here. Hey, Captain Crash. How are you? So TAWS alert. Who's calling TAWS alert? Break in TAWS alerts 187. And it's coming from mode 4C. Mode 4C. Control flight during terrain. Takeoff. Alright, we probably never clear the mode 4C threshold here. Okay, no problem. Just grab the airplane and drag ourselves up here. Back onto an approach. Got something like that. There, that should shut up mode 4C. Ever crashed yet? No, not yet. Working on it though. Take a sip. Okay, so we've got gear up. Flaps landing. Okay. Okay, that's the gear horn.
Pull up.
That was mode 2.
500. Too low. Terrain. Too low. Terrain. Minimums. Too low. Terrain. Too low. Terrain.
Okay, it shouldn't be saying too low terrain in that region there. Let's just check. Who's doing the yelling here? Back trace is again mode 4C. Shouldn't be mode 4C here. Mode 4C is for after takeoff. Active after takeoff when the gear flaps are not in the landing position. Also active during a low level go around. How did you get armed, you idiot? Mode 4C should never have become armed. Hey, mode 4. Mode 4, mode 4C. If these are in the landing config, that disarms the mode. Scrapping jet. Mode 4C active. if we are below the trigger radio altimeter and we're climbing, the trig RA should be 200 or something feet. We haven't gotten anywhere close to that. Mode 4C 271. Trigger RA. Yeah. Pause. Mode 4C. Armed. It is not armed. So how the hell are you calling out, mister? Mode 4C armed. What the fuck? Okay, that should not even have been possible. Apparently that's not even used. Good stuff. Mode 4. RA limit. And you're active, aren't you? Yes, you are. How did you get active? So, if we have no radio altimeter, which is too high, we're on the ground. We've got gear and those. Active is false. So how the hell did you become activated? I want to know. So we'll drag the airplane back up somewhere. And time accelerate down. Rip IRS. Yeah, they're not all that fond of me suddenly repositioned into a different spot on the planet. Not usually how physics goes. Actually, hang on. Can it be activated in some different manner? Active. Only there. Okay, so that's the only spot it can come from. Okay, yeah, that's still here.
Minimum pull up. Too low. Terrain. Too low. Terrain. Too low.
What the hell? Don't tell me it's active again. 276. What the fuck? Who the hell armed this mode? It should not be possible. Pause. Who the hell touches that variable? Only one spot that it's getting armed in. What the fuck? We do have a breakpoint here. Oh, okay, yeah, I know. Bit of an idiot moment here. Actually needs to disarm when we get above a certain radio altimeter. I didn't actually reach the... Yeah, I know. I know what the problem is. So there should be a... It should cease when we get up to a certain radio height. So that's for a jet, for a turboprop. Okay, 750 or 1,000 feet. Good stuff. Okay, so or RA is greater than. So or cause strapping jet or not jet and RA exceeds 750 feet, or we are a jet, exceeds 1,000 feet. Okay.
Too low. Terrain.
Reload. Now if I go above like 1,000 feet or something. Now just quickly check inside of the code here. We'll go ahead and break at 278. Okay, so it's not even getting there at this point anymore. Yep, and it's stopping in there. Good stuff. Okay, so mode 4 now should shut up. Just stepping on the other modes there. Okay, cool. So we've got gear up, flaps, landing. So we should be triggering mode 4 A or B. I think A. Oh, they're both actually different. So mode 4A is landing gear. Mode 4B is for flaps. Systems PL21 conf, and I'm going to remove that debug strap in there. Do a quick TOS reset here on the computer. I just changed some settings.
1,000.
Okay, TOS is back online.
Approaching minimums. Pull up. Pull up.
Yeah, that was mode 2. Freaking out a little bit.
Minimums.
Mode 4A should definitely have you started yelling at me now. Okay, so what is your problem? So if there is nothing valid, or we are on the ground, or IS is less than that, that's mode 4B. For B, caution zone A. Okay, so let's break in 173. Okay, delete the breakpoint. Go there. Definitely not on the ground. We don't have landing gear selected down. We have flaps landing. Okay, yeah, I know. Yeah, use the mode 4B envelope. Get MTC. So minimum terrain clearance for gear and terrain. Huh. Hang on. Actually, yeah, I did fetch that. So RA currently is below the gear caution. Use mode 4B. So are we in the mode 4B area? Not yet. And the mode 4B area is much tighter. It's 100, 200 something feet. So we were just outside of that. I got 320 feet. So continue.
Too low. Gear.
There we go. That's what I was looking for.
100.
And auto throttle should not disconnect it. So okay, yeah. The ATS currently is not. It's not going to retard power.
40.
So go ahead and give it the beans. Good stuff. Hey, Mattia. Sorry for not noticing you. How are you, my lovely? I'm doing well myself. Up at 4K. Actually make that 3,000. Because what I want to do is I'm going to uninhibit terrain awareness. We're going to play around with this thing. Just deliberately deselected terrain here to show you that there's a feature inside of the JIPWIS functionality here. It's called terrain auto pop-up, where if I go and head towards terrain, and if it does a predictive terrain alert, at this point we are running into that hilltop there. You can see that our horizon line is below it.
Terrain, pull up, pull up.
And it's automatically selected terrain display.
Pull up, pull up, pull up.
And zoom the range into 250 feet. Or, sorry, not 250 feet. 10 miles.
Pull up, pull up, pull up, pull up.
I might get some secondary alerts here.
Terrain. Too low, terrain. Terrain. Pull up.
So now it should be sort of looking around the corner for me.
Terrain.
It will be searching a little bit to the left while I'm in a turn.
Pull up, 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 pull up.
It's not a radar though.
Pull up.
People could keep calling it that, and I can't seem to get it out of them.
Pull up, 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 pull up. Pull up, pull up, pull up, pull up.
Now, funnily enough, the actual display method here, I've talked about this on Discord, but the protocol that's used, I don't know what the plugin is called. What plugin? Oh, right, that X-Plane plugin, right. This is not what they call terrain radar in X-Plane. This is completely custom code, so no, it's not using any of that. Yeah, I don't... It's the terrain map. Or JIPWIS terrain. Or one of those, but... Database terrain.
Terrain. Pull up. Pull up. Pull up.
Anyway, so funny story.
Pull up. Pull
Even though this is not actually a radar image, the display protocol that's this being sort of piggybacked on is airing 453, which is normally used for terrain display data. So I'm sorry, for radar display. So airing 453 specifies that's why the thing is sort of scanning around like a sort of a radar, because that's how it works internally. It sends out it basically sends out packets that are 1600, I think, bits long, and each of these 1600 bit packets is a single scan line here. It sends them fairly frequently, like, you know, every few microseconds, to basically simulate as if this was a virtual radar that's scanning. So that's why you see these scan lines originate like that. But that is not actually a radar image. There's no radar going on in there. You know, we could call this some kind of radar. It's faking being a radar to your avionics, just for the fact that radar displays are older than Egypt was terrain. So it's basically sort of making you think like it's a radar, or it's making the avionics think like it's a radar, but it isn't actually a radar. That's just for compatibility. Now that does not mean, so underneath the GIPWAS does not render the terrain in sort of a scan line fashion. That's just the transmission method. Internally, the GIPWAS always has the image as a single frame buffer.
Terrain.
Fail.
Huh, it should not have let me do a toss test. Gotta check that. Why did you do that? Should have told me off, or basically ignored me. Toss test. Pre-test checks. Oh, okay, yeah. Pre-test. Right. Start brief, begin stage. Yeah, I gotta remove this, or remove this up. Your IAS greater than 40, ground speed greater than 40, or feet per minute less than 30. Yeah. It must not let me. What the hell did I do? Okay, I probably left some junk in here. 270. Okay, yeah. Feet. So it's just when you realize you called that thing the wrong name the whole time. Yeah, so it's internally that the GIPWAS computer has a frame buffer that is redrawn in essentially an instant, right? So it redraws it about once every second. It's just sending the data out to your display via a radar-like method, just because that was convenient for compatibility with existing avionics, but it doesn't actually mean that there's any radar in there at all. So now if I flip you, okay, nothing happens. Good. Shouldn't let me do a GIPWAS test in the air. That is not a supported mode of operation. Now, another thing you might notice is if I go, you'll see it right now, I've got very little terrain displayed here. So I'm fairly high up. Now if I go and initiate a steep descent, it's going to start painting on a lot more terrain. But if I level off here again,
25.
terrain's gone again. So what's going on there? And it's because of the fact that the terrain display and this peaks display here as well, what they are is they're sensitive to your rate of descent. So if you are descending at more than 1,000 feet a minute, they shift where they consider your aircraft to be by 30 seconds forward in time. So if they basically, it extrapolates your descent down by 30 seconds and then uses show you, then it uses this kind of a coloring scheme for where it thinks that your aircraft elevation is gonna be in 30 seconds. If you're level, you know, within 1,000 feet a minute of a descent, then it's basically going to be always at the aircraft altitude. But if you're descending, it basically projects where you're going to go down. So it's sort of a pessimistic view of the terrain. When you understand correctly, GIPWAS doesn't rely on any ground sensors, but more internal. Yeah, it's completely an internal database. There is no sensor for terrain that GIPWAS looks at. That is sort of by design. Because not everybody... So one of the problems with ground radar is that it is extremely let's just call it marginally useful. Terrain radar is very, very noisy. It doesn't give you a very exact picture of what you're looking at. It's just about good enough to, you know, sort of avoid a hill if it is very close to you. But internally, but as a matter of like figuring out where the actual threat is, it's not really all that useful for a long-term projection. Now, there are, you know, military aircraft like the F-111, I think, and a bunch of others that have terrain following with radar. What they do is they scan very, very rapidly, a very narrow window in front of the aircraft, and all they're looking for is to establish a sort of ramp or profile of the terrain, and they'll just try and follow it with the autopilot. That's all they do. They do nothing more. They don't actually try and paint a three-dimensional picture of what's ahead or around you in any kind of a meaningful distance. The thing can probably look ahead maybe half a mile, somewhat reliably. Yes. But they are very, very limited in how far they can see and how accurately they can see. The primary problem being is that any kind of surface scatter that you have here, you know, things like, you know, trees and that kind of fuzz essentially for the radar, that is, you know, ground clutter, obstacles, buildings, that kind of stuff. I've got nothing visible here, but that's probably because I got terrain or ground detail turned off or very, very low. Do I actually? Yeah, I've got world objects too low. So those would scatter the radar beam all over the place, and you get like a haze there of stuff to look at. And it gets very, very confusing, especially also the fact that anything that is masking something else behind it, you wouldn't be able to see with radar. Radar is like a flashlight. You can sort of see very, very close in front of you, but you can't actually make very good strategic decisions on where to go with it. You need a terrain database for that. And the military aircraft do actually use a combination of terrain data with a radar. So yes, the Tornadoes and F-111s, I remember Tomahawks, actually, they are able to follow a ground contour, which I think they use like an optical sensor for that, but either way, you could use a radar to get like a very accurate picture very close in, and on further, you know, further strategic decisions where how you want to navigate around terrain, you'd use something like a terrain database for that. Cool. So hold the current position. So that was
2500.
Terrain Awareness, TAD. And we got TCF, RFCF. Those are not all that great to look at because they're just additional alerts. So PROMSO, right? Use explains database in this case, or will this be able to see orthos DSFs too? So this is using the digital elevation maps. So the way that this basically works is we are looking, I have my own parser. This is actually this code is open source, and it's also in the TBM, so that's how that thing works. This is using the same underlying database method. You look inside of Explain resources, default scenery. We're looking for DSFs. It's going to be in global terrain, right? Systems. No, it's in global scenery, right in here. Right there we go. So it's basically looking at the DSFs. One of the portions of the DSF is a digital elevation map. Inside of this is actually a 7-zip archive. Well, it's a 7-zip archive of a big binary file, and the binary file, if you write a parser, which I did, you can actually get at, there's a bitmap encoded inside of it with each pixel representing, I think, a 30 or 100 meter tile of elevation data. And with that data in hand, we can generate a three-dimensional representation of the terrain here. And by the way, that database is also what's driving the synthetic vision display here. So it's basically generating a terrain mesh based off of the elevation data. And since it is not actually reliant on Explain's explain having DSFs loaded because I parsed them myself. Therefore,
2500.
I have no problem parsing it out as far as I need. So I can easily go and parse out the entire planet if I wanted to. Now, the JITWIZ in the Challenger, or rather Honeywell JITWIZ, is limited to 200 nautical miles, I think, by default. So it will not display terrain that's more than 200 nautical miles away. If you try and zoom out further, it'll just stay at 200 miles. I actually need to put a message here that terrain range is different from what you have displayed. So if you try and zoom out further, it will not show that. At least, though, 200 miles. Honestly, that's a half hour trip to get to the edge of that display range. The funnier part is Ortho, as far as I know, overrides the global DEM data, so it looks like the CL650 can pick that up too. So if Ortho includes a DEM, I think it's hard coded to use the XP. Oh, no. It's using whatever DSFs it can find. I think we do search DSFs for scenery add-ons, so those should be represented correctly. The difference being that where the alternate 3D objects cover the mountain peaks. In those cases, those will not be seen because we upgraded 3D cockpit design. Yes, Petrochi. Yes, it will be changed. This is very much a placeholder at this point. Yeah, so 3D mountain peaks. So here's the thing. They don't have to use DSF terrain for us to be able to see it. The digital elevation map inside of DSFs is a separate piece. It's not so DSFs really contain, if I want to be talking a little bit technical here. And this is a technical stream, so let's go and file format specifications, DSF. Where's DSF file format specification. So you can actually get at it. This Laminar does publish this. So it is a stable format, and it's a kind of tree structure. Just using some sort of image here. Okay, yeah, image now found. Great. Anyway, so they use a similar format. If you know AVI files or MP4 container files, they use what's called the tree nested atom structure, where the file is essentially separated out into chunks, and chunks can contain other chunks, and essentially it's kind of like, it forms like a tree of elements, and blah 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 blah. There's a head atom, that's just a header, definitions, and so geometric data called a geode. So what these are, this is your actual terrain shape. So if you look at explains terrain mesh here, that if you could see underneath, that's actually a triangulated geometric mesh that's encoded here in the geodata atom. That's basically forming the bulk of the DSF data pool. So that'd be probably, a DSF can be several megabytes, so this would be like 95% of the DSF. At the tail end of a DSF, there's an optional piece called a raster, DEMS or a raster digital elevation data, and this is what I read. So it's essentially a pixelated top-down view of the terrain or that tile, and what it encodes specifically is it encodes your commands atom. So this is for generating. Actually, commands, by the way, is how explain places objects. So if you've got any kind of by the way, same thing for roads. Roads are part of commands. Anyway, so digital elevation maps, as long as this DEM data is encoded, then it'll work. As long as you pick the last DSF in the loading order, you should be fine. Well, I mean, we'll pick the first DSF in load order that contains a DEM. So if there are DSFs in the chain for, let's say for this tile here that do not contain a digital elevation map, then we'll skip those. We'll pick the first one that actually does provide a digital elevation map. And there's also, by the way, a fallback feature in case some people only ever use, so I don't know if Ortho4XP still does this, but back in the day Ortho4XP used to not ship DEMs inside of their DSFs, because really it's only used for elevation maps on avionics inside of X-Plane. Same thing for, I think the G1000 also uses that. So back in the day when Ortho4XP was not quite aware, yes, it's using the scenery packs, INI, Pilsner, exactly. So Ortho4XP used to not ship a DEM. Now that would be a problem for those guys that were using, only were using Ortho4XP scenery, nothing else. And so those guys would then end up with essentially nothing, right? So there would be no base underlying mesh. They'd only use Ortho4XP mesh, and there would be nothing base installed inside of the simulator. So my parser could not actually detect anything in there. I have worked around that. Let's see, do I remember where it is? So there's another data piece inside of X-Plane. They call that the, let's see, it should be here in the code. So, open GPWS, source terrain. No, it's planet. So there's a fallback method for cases where we were essentially able to use X-Plane's planet-wide texture. Yeah, I'm not sure either what it does. Anyway, DSF. This is the parts of the DSF loader. Load them DSF. Yeah, sure. DSF parser is actually part of libACF utils. So here's where it does the DSF load. Blah 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 blah. Water masks, okay, getting warmer. Tile set, render them tile. There we go, Earth orbit textures. Yeah, there we go. So that's where these are. So they would be in X-Plane, resources, bitmaps, Earth orbit textures. So here's what these look like. Let's pick one that actually has something on it. Whatever, not quite. There we go. So you'll notice it looks somewhat strange. If I zoom in, you should be able to see it on stream. So what these are they are normal maps and height maps for your world terrain, for in case you want to be looking at your planet from a very, very far distance. So that's what X-Plane uses. Now, one of the the trade-off is these things are not very high resolution. In fact, they're fairly low res. Let's see, this is about north up. Anyway, so these are fairly low resolution. You could, see that the pixels are somewhat chunky. But the difference is these always ship with X-Plane. You'll always have these, and even that 100-200 meter resolution is still better than nothing. So you'll have fairly low resolution fallback terrain, but you'll have something to drive the GPWS and to drive the terrain display here on the synthetic vision system. If you have UHD mesh, I think UHD mesh does come with DEM data inside of it, so you'll have high resolution DEM data, and that'll work. I've already tested that a while ago. So that's all fine and well. The initial release of when the TBM came out, it didn't actually have that Earth orbit texture feature in it, so it was prone to not have any terrain if you were, very, very, very. If you were flying only Ortho4XP, people will complain, and I don't have terrain on the synthetic vision system. I'm not getting any terrain alerts or that kind of stuff. I've gone ahead and implemented those a while back. This is not actually unique. That's already in the TBM, so you have that. So don't worry about it. Just go ahead, use whatever terrain provider you want, and you should be good. And keep in mind your terrain display on a synthetic vision system, or in the terrain, alerting functionality might be somewhat chunky if you're only running ortho 4xp with no dem data inside of it, but at least you'll have something. Good stuff. One of the sort of tricky parts or funny parts to do on this was glad I could help. So one of the tricky parts here is figuring out, so how does this work, right? How does it actually, you know, not completely tank performance? So even though I am showing you, you know, 200 miles away, that's thousands upon thousands of square kilometers of terrain. How does it actually not affect performance almost at all? If I go here, you'll notice if I go to profiling, when you think this plane will release. Petrochi, it's hard to be sure. We do have sort of a semi-firm release date, but we're not, you know, we don't want to get people's hopes up so far, so we're not ready to announce the release date yet. Definitely this year, though. Anyway, so if I turn on profiling here, this is the actual terrain awareness computer, TAWS, running inside of its own thread, and you see the amount of CPU percentage points of time of a single core that it's using. So this is single core would be 100% here will be 100% time spent on a single core. Doesn't mean 100% of your CPU total, just means one core. So it's using currently 0.24 percent to do its terrain awareness thingy, whatever. So it's about, you know, that much. So this is sort of the actual computer part. That's the thing that generates the image here, or the images that are then transmitted over to the displays. Now, it's a little bit more complicated than that. So in reality, the image, the ground proximity computer, if I go and bring up some imagery here, let's just go ahead and start painting on. So does this plane have some kind of automatic avoidance autopilot? No, it doesn't. I'm not aware of any aircraft that actually has anything like that. Auto TCAS, I know modern Airbuses have auto TCAS, but not automatic ground proximity avoidance. Well, unless you discount, you know, your military aircraft, those guys are a little bit weird. They do all kinds of weird stuff. Now, it wouldn't fly in the common use market in the civilian sector. Hey, CL650 pilot, how are you? So, let's call you LPFD, or rather, I'm just going to call you PFD. So, quick description of the wiring or system architecture here. So, you got your ground proximity warning computer, GPWC. So, this guy here, or sometimes called the TAWS, whatever. You get the idea. And let's see. Actually, gonna copy you like so, and I'm gonna copy. Which one of these is a fucking copy? I hate the new look at this. Yes, okay, I guessed. I hate these new style icons on everything. They are absolutely unreadable. Gathering, wow, neat. Cool. Anyway, so here's about how the aircraft architecture works out. This thing over yonder, and this thing over yonder. Cool. Modern software, you have to hold 10 seconds over each icon to know what the hell it is. Yes, I hate that. fucking crappy. Anyway, so this is how these are wired up. So this is terrain 1. This here is terrain -2. What these are airing 708, I think, /453 data buses. Airing 708, 453, it's 709. Just call it 453. I know for sure that they're that designation. So what these are is high-speed data buses that go from the JITWhiz to the respective PFDs. Then you've got a bunch of passive link-throughs that then go like so. Now internally, this is not actually all that big a deal. This is actually internally just wired through. So for our purposes, this is basically coming into a UART, or rather that's not going to be a UART. This is actually coming into an FPGA. So internally here, not RPGA, it's an FPGA. Each of these guys has a programmable gate array. I said all of them like that. A part of, oh, fuck you. I hate this. Anyway, so what all these do is essentially, fucking hell. Anyway, practical upshot is this is how the ground proximity system works. So the image is actually generated on this guy here. He then sends out scan lines. So over here, it's a full raster image. So it's essentially pixels. Then it gets sent out as a sort of a scan line image. So it basically looks like a radar beam scanning over. And then on the other end, this again inside of the FPGA here is reconstructed into pixels. So that's how this transmission system works, and we simulate that. So if I go here into my data bus display, I can actually find terrain 1 and 2. And if you look, there's a little scan beam running around in there. And this big data blob, that is your terrain image. So for practicality reasons, I didn't simulate the actual scan lines being individually sent out over the data buses. It's just not practical. The reason being is that the underlying transmission method here relies on microsecond precision timing. So this would require, microsecond precision to time correctly, and there'd be hundreds to thousands of scan lines being, hundreds of scan lines being sent over that data bus. Bye frame rates. Yeah, it's worse than that. It's that and the fact that internally the simulator, if you're looking at game/simulator/ whatever kind of deal here, 20 milliseconds is sort of your typical realm of where you're going to be existing. 20 milliseconds plus or minus whatever is the sort of stuff that you're stepping of your simulation, and that's really the reasonableness of CPU scheduling. If all of a sudden I try to do everything at like 0.01 millisecond accuracy, 10 microseconds, that would require so much CPU scheduling overhead that you'd basically be paying a huge penalty to go from here to here. So I don't do that. Rather, the JITWhiz, what it does is it sends out a complete image every second. So this is actually a 240 by 120 pixel, 8 bits per pixel paletted image. So it's 28 kilobytes every second, or 29 kilobytes. You can actually see the data rate here of transmission is 225 kilobits per second simulated. And it then sends out a sort of supplemental piece of information, like here's roughly, this is pretend here, this is where I'm scanning. And then that information is used by the frame buffer reconstruction here to copy only pixels along the scan line out of the input image into an output frame buffer. And if I show you what that looks like inside of the code here, it's over in terrain.c. And actually, no, not here. It's in display AFD522E. And it's going to be down at the bottom there because it's some new code. Probably not. Where are you? Render callback. No, it's going to be up in above the main function. There we go. Scan, transfer to scan line. Okay, so handle terrain input. Blah, blah, blah comes in here. It constructs an ARGB surface for compositing functions. So the display is actually, you know, RGB 32-bit per pixel, but the input image isn't. So what it does is every time it looks at a scan line, so this image here, the actual display animates at 20 frames a second. So this comes through here 20 times a second. That's once every 50 milliseconds. By that time, the scan line will have probably moved along quite far. It then goes through that from its last scan position to the next scan position, or wherever it's ended. It goes in like quarter-degree increments, and it basically copies line by line each of the pixels along there, and it goes through on both sides, so left and right. And here's the little scan line transfer thing. And so what it does is it goes through, picks up a pixel, so basically determines first the coordinates, picks up the input pixel. The input pixel is 8 bits per pixel, so uint 8t. And then it goes through an EGA palette lookup and shoves that out into a full RGBA 32-bit pixel. And the EGA palette is defined up here. So this is just standard EGA palette stuff. If I go over, you'll know that it's essentially this table just displayed as, or translated into actual data. So yeah, that's how that whole thing works. Whoa. Did my stream just die? Oh no. Hopefully we're still alive. Okay, my windowing system here freaked out a little bit. Fortunately, we're still good, I think. Yep, we are good. Cool stuff. So that's how that whole deal works. And yeah. And the funnier part, or I guess the more sort of fascinating part, is not on the consumer part. That's just the way that the image is actually finally projected. The more interesting part is how it's generated. How do you go from DSF terrain elevation maps over to an actual, you know, even an EGA image, right? So that is done here in the TOS computer. And the TOS computer, so you could theoretically, you know, if you wanted to, you could just go through every pixel that's sort of supposed to be on the output image. This is, by the way, a 240 by 120 pixel image. You could go through every pixel, run a coordinate transform on it, and, you know, look it up inside of the textures and blah, 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 blah. Doable, but I wouldn't call it efficient. The hell? Some dog barking. Neighbor's dog is absolutely going crazy for the last few weeks. Stupid dog. Anyway, it would not be extremely efficient, let's say. And the way to do this is, if you know stuff about GPUs are extremely efficient at, can y'all, by the way, still, you know, hear me and see the stream and everything, because I haven't been seeing any messages. And I'm kind of worried that my windowing system freak out there kind of broke the stream. I think the stream's still running, at least in my window here off to the side. Okay, cool. Thank you, Zika. Cool. So it would not be very, so one of the things that GPUs are extremely efficient at is taking textures and then rotating them and projecting them onto a display screen, right? So that's what GPUs are very, very efficient at. It's acting like a mask. Yes. Right side of the line is where the old image is, and the pixels in the buffer are copied exactly. You see, I think the aviation term all the time. Yeah. So high tune, I'm talking about a graphics processing unit. So that's how we do it here. So whenever the TOS image or whenever the TOS system comes around here, let's see. So TOS terrain update. So this is called externally every about 1 second. Well, it's actually called 25 times a second, but there's an internal timer that avoids re-rendering too often. I'm confused for the moment. Discord too. Okay. So the TOS image here, for it to be, so normally the way that the TOS images are kept inside of the avionics is as individual tiles. So they, if I go ahead and use another picture here, drawing time, I guess. So let's say your aircraft is over, here. And so the way that the TOS works is it basically looks at your position in space and then says, okay, I want to have terrain available for at least 200 nautical miles away from you. So then it starts loading in DSFs, and DSFs are kept on a 1 by 1 degree grid. And by the way, the grid does not necessarily need to look like an exact square. It can be sort of more, sort of like that. Just depends on the exact shape of the terrain and blah, 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 whatever. So let's pretend that this is your terrain data. Internally, the pixels are sort of, like that, right? So they're along long lines, but your display is looking at it like this. You want to find a way to make this kind of data look like essentially a pseudo radar display, something like that, right? So you're basically trying to draw textured tiles. This is your view, and this would be your terrain data. So this is what GPUs are extremely efficient at. That's the whole thing. Sort of their whole design goal is to take, hey, Jazz Junkie, welcome aboard. So that's the entire function of a GPU, is to take, polygonal data with textures on them and project them onto screen pixels. So this is your screen here. This would be your screen pixels. You're trying to find a way to map the underlying terrain data or onto screen pixels. And that's exactly what GPUs are very, very good at. So what I then do is I basically take, there's some timing stuff here, and one of the sort of side effects here is that the TOS is running inside of a separate thread, right? So it's running inside of a background thread, which does not have direct access to the GPU. It could be done. It's just for practicality reasons, or rather for simplicity reasons, I didn't need to create my own OpenGL context. OpenGL contexts are kind of weird in that they're always bound to a specific thread on the CPU, or specific process thread. Sorry, not specific hardware thread. I'm talking about a process thread. So normally in X-Plane, you can only access OpenGL state from the main thread. There's a way to get at it from other threads, but for simplicity reasons, I didn't want to bother with it here. I'm going to explain why. So instead, rather, what happens is whenever every second or so, when the TOS wants to draw a new image, it generates essentially a render request. So it basically encodes all the information that is necessary to draw the image. So we do want to do a draw, yes. This is our position. This is our heading. This is this map range or scaling that I want to be applying. Display size. So this is basically the scale of the image. And then offset is where on the image the center point or origin point of the aircraft is. Otherwise, it'd be, on the lower left edge. Hey, hello, 73. Welcome, welcome, welcome. So, and it generates a terrain render request. Thank you. I'm going to get some more tea. Oh, and water. Perfect stuff. It's fairly hot here, so gotta keep well hydrated. Anyway, so it generates a terrain render request here. Let me just quickly turn on my camera again. Hey, El Promo, how are you doing? It generates a terrain render request, which is handled in a completely different part here. So it's regularly called up here. So this is a draw callback from X-Plane that is basically invoked every frame, but it doesn't generally do very much. So it just comes in here, looks at, do I have any kind of work? So it grabs a lock, looks at render stage. Are we in a request stage? 99%. After COVID, meanwhile, quite well. Hi. I hope you don't have any lasting damage from that. Anyway, so it gets so if it sees a request, it'll honor it. No, 99% of the time, there's not going to be any requests there, so it's not going to do anything. Comes in here, then it's just got a terrain render request from the TOS thread. So this is running on the main thread, by the way. So on this code here, we want to make sure it runs as fast as possible because we are taking up CPU time for X-Plane to be rendering terrain. Terrain render request comes in here. And what that does is it does a whole bunch of stuff, but render starting, it binds a new frame buffer. So that's going to be the frame buffer for the TOS side of the image. Sets up some viewport graphics state, blah, 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 whatever. Grabs a shader, and then here's the shader selection code, which you looked on Discord and developer earlier, I think yesterday or something. I posted where I have several versions of the shader. So this is where the selection code goes in. One of the things about shaders is GPUs really, really hate branching in shader code. So that's essentially code that runs pretty much on a per pixel basis. And they really, really hate to have that running doing branches because branches are sort of unpredictable and GPUs are not really efficient at them. They can do them, but it slows down the shader's execution. So ideally, rather than selecting what the shader does inside of the shader, rather you compile multiple versions of the same shader. So, well, here's the version of the shader with gear down. Here's the version of the shader with gear up. Here's the version of the shader when we have terrain impact and gear down. Version of the shader with predicted terrain impact gear up. And then there's some other stuff being done here. And it feeds the shader a bunch of information, blah, 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 blah. And finally, it then runs this function here, which is a function inside of OpenGPWS, which, which then actually takes the polygonal data and runs the actual rendering. Then we have a decent branching implementation since CUDA, which is specific to graphics. No, so Hytune, you can do it. It's just more a matter of it's just inefficient. It's just an inefficient use of GPU resources because GPUs, they execute. If I think the term, I forget if it's the AMD or NVIDIA term, but they're called GPU shaders generally execute what's called a warp. And that basically means that each of the what you call CUDA cores, or rather, really the way GPUs execute is, I think NVIDIA calls them streaming multiprocessors. Yes, NVIDIA calls them streaming multiprocessors. AMD calls them compute units, CUs. These are effectively compute cores. But the difference between these and your normal main CPU cores is that, first of all, they are very, very simple. And second of all, they have massive multi-threading inside of them implemented on a hardware level, meaning they effectively have sort of a single sort of execution pipeline. So there's an ALU in their arithmetic logic unit. but there are many threads of execution state available to the GPU to pick from at any given point. And these are most efficient when so these are executing, each of these are executing or fetching instructions for a shader. A GPU is most efficient if all of them share effectively the same state across a single shader, or rather the same instruction status. So if we look at the shader code here, plug in a system source PL21 shader source, right? So TOS. So this is what the shader looks like. Finally, these get boiled down into actual executable instructions on the graphics processor itself, but the difference is that they are most efficient if they all execute in lockstep with each other. That effectively means you don't want to have any kind of conditionals here. So if there were like if something, then do that, and otherwise don't do it, just skip it. That means that one of the threads, if it does hit this conditional and it does sync inside of it, whereas some other thread might have hit the conditional, didn't meet the conditional, and just skipped on ahead, that effectively means that they are now out of lockstep. And then the GPU has to do some more, synchronization work between them. There's some more branching, considerations and CPU cache fetch synchronization. And it basically just becomes less efficient to execute on the CPU or on the GPU. So if you avoid this, you're most likely to get the most efficient execution. If you know you're there's a feature in NVIDIA's graphics debugger called Insight, which they call the speed of light. Not shit out of luck, speed of light. And so this metric there, you want to keep that as close as possible to 100%. That tells you that your GPU cores are executing without stalls, without cache misses, without basically slowdowns, generated primarily from branching. And to facilitate that effective execution, GLSL here, the shading language, has multiple features built in that avoid branching. So one of the features, for example, here is the clamp function. Clamp function, what it internally does is it gives clamp function is something like this, x is less than or equal to 10, which is less than or equal to like 0. And so you'd say, y is equal to that. So basically what you're doing here is you're constraining the value of x here to between these two values. The traditional way to implement that in C or any kind of general purpose programming language would be to say if x is less than 0, then return 0. Else if x is greater than 10, return 10. Otherwise, return x, And this is branches all hell. And this, for example, if this is less than 0, it's going to go right into the first branch. If both of these are basically met, then it's going to go all the way through. So basically, each execution of this is going to be slightly different length. The clamp function here essentially does this, but the difference is, since it is a first-class function inside of the GLSL language, GPUs have optimized these, and they have specific microcode that avoids branching or avoids desynchronizing the execution of your CUs by having this essentially built in, this kind of a routinely used mathematical piece of functionality. Same thing for step, by the way. The step function is basically looking at a boundary condition and the actual value, and it does effectively this kind of a thing, right? So that's what's called step, is because it does this. So this is your boundary, and if the value that you give it is above the boundary, then the output value is 1. Otherwise, the output value is 0. So it does this. Normally, this would be again done through a branch, but because it's built into the language, you don't have to use an explicit branch, and you can just rely on the GPU's shader optimizer to figure out a way to get this to execute efficiently on the GPU. So it again explicitly avoids a branch. Yep. And this is why GPUs are extremely efficient at executing certain tasks. A general purpose computing task on a GPU would be insanely slow because of the fact that they have very stupid branch predictors, very, very limited ability to prefetch data. Instead, they rely on having just insanely high levels of parallelism of number of concurrent tasks running. you can quite easily understand why that is the case, because if you're executing a shader for every single pixel on screen, those are thousands of shader executions. So the GPUs have thousands of parallel threads executing through them, and they just rely on just brute force sort of swamping the problem with execution rate, total accumulated execution rate. And the effective method to do that is by using as many of these built-in shader branch avoidance functions as possible. Now in here you'll notice I've got a for loop, and I've got an explicit set of if conditions. This is a case where shader or branch avoidance is not possible. This is because this data is, by its very nature, this is the impact point rendering. So where it draws when you've got a set of points where it predicts an impact, that is necessarily going to be a different number of impact points every render. And you basically want to determine your distance from the impact point, and based on that shade the picture or the pixel indifferently. Those are not easy to avoid using, these are not easy to implement without branching. So to avoid branching, usually what you can see here is this whole piece of code here is if-def. So if-def impact, if-def impact. But that means that this macro has to be defined at compile time for the shader. And how we do that is you'll notice here, I've got the same shader just with different suffix names, and I pass different preprocessor directives to the shader compiler, or rather the Ruby compiler. And so I take the same input file. It's always the same, the same TOS.frag file here going in. So it's always the same input here, 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 and here. But it generates different output files, and they are over here. In fact, if I just list the frag GLSL versions, you'll notice that there's a TOS frag, a gear, height, impact, and impact gear. And that's what the shader selection code here then does. So the TOS, embarrassingly parallel, yes. So that's what this does. The TOS knows ahead of time. Am I actually going to have to be looking at impact points? If no, I can just use the regular straight through shader and not bother with it. And that then avoids the entire branching. This whole loop almost never gets used. It only ever gets used, and the slightly less efficient coding path only gets used if you happen to have a impact predicted on the map there. If you don't, not a problem. 99% of the time, you won't have to rely on that code path, which is slightly less efficient. And if you do, you've got it. It's still possible. It's just not necessary. Now, in this case, it would probably not have made any difference if we were using that method. See? So now it's switched over to the impact point version. And it's also changed my display range down to 10 miles.
2500. Terrain. Pull up. Pull up. Pull up. Pull up. Pull up.
If I turn away, it will go back to just the regular version of the shader. Assuming I can turn away in time. I'm gonna smack into something. Alrighty. Actually, I want to go and aim for this hole here in the terrain. Good stuff. I might get a secondary caution here. Yeah, that was mode 2. It saw the rising terrain underneath me, rapidly approaching. And now it's going to shut up again. Okay, cool. And now, again, it's going to sit there for 40 seconds after the encounter, unless I climb 300 feet or more in that time. Then it will remove that message even before that 30 or 40-second timeout.
1,000.
Oh, there it goes. A little bit earlier. Anyway, so that's the way that works. Now, the trick is, now the image is rendered, but it's on the GPU, so we got to get it back, right? So we've rendered the image, but it's in GPU memory, not CPU memory. We can't get at it. So what do? Now the sort of most efficient way would be to take the same image that we already have in GPU memory and just composite it onto the screen here. That would be a way to do it, but it would sort of bypass the avionics architecture, which I don't want to do. So instead what we do, we send in the render request, and once the render request is sent in, I take a little object here called a fence. In GPU execution, a fence, or rather a sync fence, specifically GPU commands complete, the way execution works in OpenGL or any kind of basically modern graphics API is that the GPU and CPU execute independently of each other. So here you've got your CPU, and your GPU, and they're not actually in lockstep at all. Rather, what the CPU does is it generates what they call a command list. These are all individual pieces of command to the GPU. So command. And when I do this kind of rendering here, or any kind of these operations, what they effectively do is they generate command sequences, right? So it just generates a command sequence and then punts it off to the GPU to be scheduled for execution on the GPU. But sometimes we do want to synchronize them, right? Sometimes we do actually want to, know when something has completed work. So as a last step here in the sequence, we generate a little sync command or a sync object. And what that does is when the GPU is chomping through that command sequence, when it gets to the sync event or sync object, it sends a little message, again, asynchronously back to the CPU to tell it, hey, commands have been completed. Whatever you ask me to do is done, and it's ready to be processed. So on the CPU side, again, this is all CPU code. What this does is it basically just creates a reference for me to ask. I can't on the CPU driver then, so I'm sitting here running on CPU, and I can go and ask my OpenGL driver, hey, has the sync request yet, has it been received? Has the execution completed yet? And if it says yes, all good. If it says no, then we basically wait on, and it's the way it works. So here we also do a scheduled back read of pixels. So by the way, I kind of skipped here. So when we do the render commands, we also do a bind buffer. I generate a little piece of memory or allocate a piece of memory here on the GPU called a buffer. And I tell it, hey, when you're done drawing, I want you to copy pixels from that screen, from that frame buffer, which is over this thing here, render FBO, frame buffer. Once it's done rendering the image there, I want you to copy those pixels into this buffer. And this buffer is actually, on my side here, it's just a reference to some piece of memory over on the GPU. And then when it's done, basically done all those readbacks, I'm asking here, hey, can I get please a sync object to tell me when that buffer readback has completed and been transferred back over to the CPU, because I've got it set up as what they call a pixel pack buffer. Pixel pack buffers are readbacks. So when the readback to the buffer is completed, when that piece of memory has been transmitted back to the driver on the CPU. And then I ask, hey, has everything up until here completed? And then here's a little polling function that when the render has been put into request, then it's on the on GPU stage. And then regularly, every frame, we come through here and quickly ask the driver, hey, has the Has that piece of work been completed yet? Yes, no. And there's 0 timeouts here, so this takes 0 time effectively. It's just me asking the driver, has that work been done yet? No. Okay, I can wait. And so whenever this actually returns timeout expired, that means work is complete. We can go ahead and pick it up. That means that that rendered image has come all the way back from the GPU's internal memory, all the way back through the driver, and I can now read it. It's on the CPU's side now. So I can go ahead and ask, hey, can you please map that buffer for me? And once this then returns a pointer from which I can then read back the image. I can unmap the buffer again. So basically just tell the driver, I'm done here, thank you. And then I recycle the sync object and I set the render stage for the TOS thread to render is complete. Image is ready. You can go ahead and pick it up at your earliest convenience. And if we go up here, this is the TOS thread again coming through, and it sees, hey, render is ready. I can pick up the image. So this is again all lock protected, so we don't actually desynchronize anything. We transfer the image, set the state to render idle. We're done. And then we do a update for the overlays. So this is basically just using there are some overlay textures and some imagery that we can composite on there. Primarily the test image. So if I go and unpause this, let's go kill the autopilot, kill that. Full power to idle, and I'm just going to quickly put the airplane down onto the ground.
Too low. Terrain. Minimums.
So if I pause here, come on, stop already.
Pull up.
Yeah, it's gonna be fairly unhappy about everything I've just done, but it'll get there. And so the overlays are for things that are like the test image here.
Glide slow.
So these are completely GPU, or I'm sorry, CPU generated images. So these don't go through the GPU at all.
Terrain. Pull up.
And I'm gonna switch the format here over to something different. Anyway, yeah, so that's how also the TDB texture, how that's generated on there.
Glide slow. Pull up.
That'll be your terrain database version.
Wind shear. Terrain. Pull up.
And by the way, also the reason why when you have because even when I disable terrain display here or set the zoom to something different, as soon as I do a test, you'll see the thing switch over into terrain display mode. That's why that's the terrain alert auto pop-up coming up. So when I do this, as soon as we get an alert here,
Glide slow.
these automatically enable terrain display, and it's basically showing the terrain data,
Wind shear.
rather the test pattern only.
Terrain. Pull up.
How does your terrain or radar use X-plane data or real-world data? I can imagine probably some mismatches. It uses whatever terrain elevation map you have in X-plane. So whatever is inside of your DSFs encoded, that's what it's using. It's not using an external database because of what you're describing there. If you have some differences between your terrain and real terrain, that might be somewhat different. Now, it will not account for if you have something like terrain flattening on your runways or that kind of stuff. It can't see that. But whatever terrain DSF data you have loaded in, it's gonna see those. It's gonna use those. So there's no explicit, terrain database updates that you would need to do. Cool. So, what was the remaining parts of this? By the way, I don't have ROS implemented right now, Runway Awareness. I do have code for that, obviously, since I wrote XRAS. It's really just a matter of like I have to integrate XRAS to get it in there. And XRAS, since it is in reality ROS or Smart Runway and Smart Landing, since they are part of the EgyptWest computer, they're just a piece of software on it. They actually render the same image on the terrain data display. So whenever you get a ROS alert, it would actually display in the same kind of scan beam fashion as your regular terrain data. It would just sort of scan through. Since it is, that's how X-Plane, or that, I'm sorry, that's how the JITWIS sends you the actual image to be drawn. Now, not every JITWIS version or TAWS version necessarily uses this kind of a scan beam approach. It's just use Comic Sans like the A300 does. But you just saw what sort of font it uses. In reality, it's a fairly chunky font. And I try to find, I was looking for a font that is very, very close to it. So it uses this kind of a font here. And if I go ahead and delete the flight plan, you'll be able to see it.
Wind shear, wind shear. Terrain, terrain, pull up.
So this is the font that it uses. And it is actually an open source font. So I can, where is it? Gonna be in, not there, not there. Blah, 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 systems, source, PL21 fonts. It's this guy, White Rabbit. It looks something like this. Now the real JITWIS font is slightly different, but this one's the closest and open source and free one that I could find. So it uses this font here. Good stuff. Cool. I'm gonna take a 5-minute break here. You know, do your business in the meantime, and I'll see you in a couple of minutes. Don't go anywhere. All right, back in business. Yes, Pilsners, exactly. Smoke 'em if you got them. Oh, one more thing that I wanted to show you. So we've gone through most of the modes here. Don't need you anymore. So it breaks off. I'm just going to toss the airplane back into the air. there was one last mode that I wanted to show you. Mode 7. So mode 7 alerts are wind shear alerts. So mode 7 is for, obviously,
Terrain. Full up.
obviously, you know, when you're on approach. I want to get those flaps out. Now the wind shear, as far as I can tell, the Challenger does not have predictive wind shear. So there are no PWS cautions, but it does have reactive wind shear, which is provided courtesy of the JitWhiz. Just gotta put the airplane into some sort of a sensible flying config here. Put you about there, or some sort of a reasonable approach config. So wind shear cautions are generated based on the JitWhiz looking at basically the rate of change of the headwind component, right? So for sake of argument, let's say they are constrained to only below 1500 feet and above 10 feet radio altimeter, and they are using a coefficient. If I show you here, I think I got it right. Good. TAWS mode 7. Mode 7. So we've got we're using a high pass filter for the headwind component and your vertical speed, your instantaneous vertical speed, as provided by either the inertial reference system or the air data system, whichever one is operating, preferably the IRSs. IRSs are responding much faster to your vertical speed changes than the air data computer. So it looks at the high pass filtered versions of these, so essentially the rate of change of them. And if the rate of change, there is a slope here, a caution limit and a warning limit, which let me check if I can find it for you. Yes, there it is. So here's the caution and warning constraints for the wind shear system. So it's basically looking at a coefficient, a combination, effectively like a line on here. So if your headwind is increasing at more than 2 knots per second, then you're going to get then you can get a wind shear warning, or a caution rather, for increasing headwind for increasing performance. Then you've got a warning for decreasing performance, and it's basically a combination. So if you're not getting quite 2 knots per second of change, but you are getting a rapid climb, a speed of change of the vertical speed, right? So this is more feet per minute per second. So you're getting, 1 knot per second of headwind component change, but more than 800 feet per minute per second of change in vertical speed. That is also considered a wind shear caution, and the reverse here is down for the warning. The easiest way to show you, unfortunately, I think I don't know. Tell me, but explain. I haven't found the wind shear trigger to have a GUI anymore. They used to be. You used to be able to look at your. You used to be able to trigger a wind shear failure or wind shear event essentially through the failures menu. I'm going to reset my IRSs here so that we're correctly aligned, because it kind of relies on having an accurate headwind.
1,000.
Oh, whatever, close enough. On having an accurate wind component. Or reasonably accurate wind component anyway. So, if I now go ahead and trigger, SXP has wind shear trigger. Yeah, but stock, explain. Anyway, it will. You can actually get it to trigger even just using regular wind components if you are sufficiently aggressive. So I'm going to put this like so, unpause you, and watch this. So as soon as I trigger it, I get a massive headwind.
Wind shear. Wind shear. Wind shear. Wind shear. Wind shear. Wind shear. Wind shear.
Anyway, that was just me on auto throttle. You would normally be disconnecting ATS here and going immediately into full performance mode. So let's go and do it properly. Now you got to be actually below 1,500 feet radio for this to trigger, because the wind shear protection system is only active then, or the reactive wind shear triggers in mode 7 are only active then. So let's see, we're on approach here, whatever. You know, we get a headwind component burst.
Caution, wind shear.
At this point, we would be, you know, probably kind of psyched, and holy shit, we're falling out.
Wind shear, wind shear, wind shear, wind shear, wind shear, wind shear. Sink rate, sink rate.
Anyway, that kind of a deal. That was tough. Yeah, wind shears are never fun. But in order to make sure that the system actually performs, this is not just looking at the data ref, by the way. That would be a nasty trick. And you know, we're not about tricks here. It actually is looking at your components, your wind components. I'm just gonna put myself over here over water, where I can have sort of a consistent vertical position. Let's go down to like 1,200 feet. Sure. We don't have to be in landing config either, so that is sort of optional. We could go and select like approach config or initial approach config, gear up, and flaps 1. I just want to be below 1,500 feet. Now there's a fair amount of fine tuning. I gotta reset my IRSs here because I've kind of been naughty here. There we go. That was a perfect reset. Good. So there's always a fine balancing act. Let's try that in 319. Yeah, so there's always a fine balancing act between making it, you know, sensitive enough to detect the wind shear early, but you don't want it to trigger just for any old, you know, wind component or turbulence or whatever gust. So let's say we've got, you know, 30 knot, we've got winds 20 gusting 50. So that'll be a fairly brutal kind of a deal. We'll make it straight on the nose here. Actually, 120 is our heading. So let's make them straight on the nose. This will be a 30 knot variability of speed. We don't want it to trigger the wind shear protection every time we get a wind gust. So if I go ahead and I'm going to do a quick reset of the TOS computer. And hopefully now we should get some debug info about it. I've enabled some debug prints for mode 7. I think I did anyway. What did I call you? Mode 7 debug log. Okay, so you're an idiot. Yep. I need to recompile this. So mode 7 debug log. Where the hell did I move this? Oh, okay. TOS mode 7H. Okay, yeah, that needs to go away. Just go back into coding mode. And so this is gonna go ahead and be replaced with TOS debug log mode 7. There. There we go. Good stuff. Reload. Now, how would the autopilot deal with a wind shear? So the autopilot is designed to disable itself 2 seconds after detecting a wind shear. This was not it. This was just the yaw damper kicking off from the fact that I've just reset the airplane. I'll quickly recycle my IRS status here. There we go. Alrighty, there we go. So now if I go to full screen display, you'll be able to see that there's a bunch of debug info running over here, that window. So these are sort of the state that the JIT is seeing coming from the inertial reference system and all that good stuff. So here you've got your delta headwind. So this is your headwind rate of change of vertical speed in feet per minute per second, and our caution and warning limits at the given headwind. So it basically runs through here, looks at the change in headwind component, then looks for the caution and warning levels and checks the vertical speed delta against it. So it should essentially never ever, it should never consistently sit in there. So even if the headwind shear hasn't hit yet, it will kick off 2 seconds after. Only on a warning though, Pancake, not on a caution. If you've got a rising performance status, see, there we go, we had a brief caution there, but the trick is that the system is designed with a fair amount of tolerance in it, and so it's looking for a trigger delay, which is 1.4 seconds. The caution or warning state has to persist consistently for more than 1.4 seconds before it will actually declare it either a caution or a warning. Otherwise it will not. So that is what gives you your ability to have like these kinds of bumps here. These are, fairly, this was a fairly significant one, but it still isn't enough to actually cause the wind shear trigger or protection system to kick in. It was getting close, and basically you want to tune it in such a way that it is marginally on the sort of at the most extreme typical but non-wind shear yet weather. You want it to be reasonably insensitive to that, so it doesn't generate spurious alerts, but at the same time, on a genuine wind shear event, you want it to trigger as soon as possible. So there's always a balancing act between making it too firm or too sensitive. It's sort of, classic tuning problem, right? You want to tune but not over tune. Good stuff. So let's go ahead and give it something to actually wind shear complain about. Here's where I'm going to show you what it looks like when it kicks off. So let's make it 20 gusting 60. Let's see if that'll trigger a wind shear caution or warning. Now that is already a fairly significant amount of... Now X-Plane will not just generate them all the time, these 40 knot changes, but a 40 knot change, there we go. And there we go. And it's also, you'll see, normally when you disconnect the autopilot, it will give you still the flight director. On a wind shear, it's different. When it detects a wind shear, the autopilot kicks off, and it also disables the flight director, basically to avoid giving you a seemingly bogus target to aim for. To avoid giving you a bogus target to aim for on a wind shear avoidance. It also flashes, by the way, on all displays. It will, by the way, not bring up the terrain map automatically. It's designed to understand that this is a wind shear event, not a terrain event, so it will not bring up terrain auto pop-up on a wind shear. That's basically, again, to avoid distracting you, or what's really the most important part, is to get out of the friggin' wind shear. So you'll see, 20 gusting 60, that's extreme weather, you might say. Even there, it's trying not to generate the wind shear events. Oh, there we go. We might get another one. No, not quite. It reversed direction. Okay. There we go.
Wind shear. Wind shear. Wind shear.
And again, flight directors have disconnected. You would at this point punch your power all the way up and disconnect the auto throttle in reality and just push it up all the way. I mean, it does sound like regular, and by the way, it won't let me engage the autopilot while the wind shear warning is active. Just an average Chicago day. What?
Caution. Wind shear.
You can see how rapidly that headwind, and by the way, it's not looking at the speed trend vector here, it's actually looking at this. It's looking at the headwind component of your wind coming from the inertial reference system. Now that also has some springiness to it, so as to avoid, you know, generating just absolutely spurious alerts. So there's a fair amount of filtering going on. But yeah, you know, a 30 knot headwind loss is generally considered a bad day. And it won't actually generate these as soon as I climb above 1,500 feet. Oh, by the way, sensor heats need to come back on. Those are the myriad of warnings there.
Wind shear.
And since I am now above 1,500 feet, even if I trigger a manual wind shear event here in X-Plane, so go to rel wind shear and set the value to 6, just that means trigger the failure. Even if I set this manually, see, no caution and no warning either, even though we have lost what, 50 knots, 60 knots, 70 knots, 80 knots of speed. Again, it's only sensitive on approach. It's kind of by design. It doesn't want to annoy you unnecessarily. You can get fairly large swings in wind component on high up in the air, essentially. So that's why this thing is limited to 1,500 or below. Are we flying in a hurricane? Sort of. Pretty much, yeah. 20 gusting 60. Another way to get it, by the way, you might not even need you know, that amount of wind component, but if you have directional change, which X-Plane calls shearing, but really what it is change in direction. Now it's again rearmed the wind shear system. Now we're below 1,500.
Wind shear. Wind shear. Wind shear.
So now I've only got, you know, 20 gusting 50. But my word, a bit bumpy.
Wind shear. Wind shear. Wind shear.
Come on, go away, wind shear warning. I'm going to re-engage my autopilot. Takes about 20 seconds for it to clear. Basically give you enough time to do any kind of wind shear avoidance that you want. That would be a bad day. Yeah. Well, what if we crank the wind sliders as far as they go? Well, it's just going to be more of this. Come on, go down already. What? There we go. We're back in the caution range where it can. Immediately went into almost. We almost got a wind shear trigger right there.
Caution. Wind shear.
But you can see what the wind there is doing. And by the way, this is the inertial reference system, you know. doing its thing. So that also has the added effect. This only is as accurate as your inertial navigation system's ability to recognize which way the wind direction is blowing. It also relies on your true airspeed and all that good stuff. That speed trend vector is having a fun time. Yes, sir.
Wind shear, wind shear, wind shear.
It's absolutely having a party down there. Yeah. And the yaw damper, man. He's having to work overtime. I go re-enable here the autopilot, so I've got my hands free. Flight director, and you can see what the yaw damper is having to do here. I'll put it into heading hold.
Wind shear, wind shear, wind shear.
I guess 20 gusting 50 with 90 degrees of directional change is a little bit too much. What about 20 gusting 40? That one shouldn't be quite as bad. Did you have iron out any licensing agreements? No. Bombardier generally does not care. Plus, we're not calling it a Bombardier Challenger or anything like that. It's gonna be the Hot Start 650. So yeah, we're not saying that we've got any endorsement really of anything. Also, don't use this for training. If you are, I'm gonna call you an idiot. So, have a look. Hopefully now, with 20 gusting 40, it should no longer be triggering the wind shear protection system. I'd like to see you land, though. I'd like to totally say 319, yeah. Now, there's zero code here from their stuff. And again, for them, for, things like Airbus and that kind of stuff, they don't do that for any kind of engineering support. They just do it for licensing the name. Challengers 649.5. Yeah. I mean, I'm currently over water, so you can't quite see the how brutal this is of conditions, I guess, but if I bring it up, yeah, there we go. Well, this is just me turning, trying to maintain 30 degrees of bank angle. What? You can see how hard the autopilot's having to work. And yes, the autopilot does not just use trim, it does actually pitch on the yoke there, as you can see. It does use proper pitch axis input. Only trims when it is basically sort of steady and just wants to maintain a direction. Anyway, yeah, you can see how much turbulence there is. On the 650, I don't expect to see Expo major update. 2022. Probably, yeah.
Caution, wind shear.
No, we got a caution there.
Wind shear, wind shear, wind shear.
Okay, so 20 gusting 40 with 90 degrees of shear direction. is enough to trigger it. I make it less sensitive. I don't know. Kind of happy with where I have it tuned right now. It has to be sensitive enough to trigger soon enough for you to actually be able to see, the shear when it's a genuine one quickly enough, rather than just, you know, it waiting until you're in the super low speed regime, at which point the wind shear warning is kind of late anyway. Cool. Let me reset my debug strap in here. And during the entire time, I didn't get rain cautions or anything like that. That's good. This is exactly when I'm going to reset the weather here. I'm just going to point it at the terrain there. Why not? Okay, so remaining items. Obstacle warnings, ROS integration, and trapping configuration. Why the hell is X-Plane giving me like shit textures? I have no freaking idea. Like giving me textures as if I had like 512 megs of video memory or something. Whatever, X-Plane, you piece of shit. We're gonna finish this first Galzar Toto. Hopefully it's gonna be Goran, not me.
Terrain.
So start timing.
Terrain. Pull up.
About 15 seconds after the initial caution. Let's see when we would have hit. Could have been about a minute. There's some factor that we're still 45 seconds. 50. And stop there. Yep, there we go. We're just about. And it was about 57, so I started this about a second or two late. So yeah, about a minute of warning is what you get for all the initial caution, and then until you actually, you know, meet the terrain. There's some minor accuracy factor in that this is actually the terrain tiles are, or the terrain examination has happened in about 0.1 nautical mile steps. So there's about 100 meters inside the mountain where it sees the contact. So at this kind of a speed, I'm going about 60 meters per second. So that would probably account for the remaining about 1 to 2 seconds inside of the hill there. So yeah, it's reasonably close to being a minute. I might just boost it a little bit, just to account for the extra time there. That's going to give a couple of spurious warnings because it's we just repositioned. Or rather, I'm going to actually go in here into. Come on. There we go. EAD. EAD, and there we go. So, and I want to boost the outer envelopes a little bit. So 65 seconds there. Like 54 seconds there. Maybe like 64, 53. And this will be about 48, 37. So I'm basically adding a couple of seconds of extra time there. The values here for the inner portion, that is for when you're very close to a runway. We don't want to expand those because when you're close to landing, we don't want to be generating spurious alerts off of terrain that is sort of right in the immediate vicinity of the runway, We're just past the runway. Okay, so when you're going faster than 300 knots, we want to boost the warning ranges out to like 63, 73, 73, 84. When you're going very, very fast, it gives you extra time to be able to detect a potential conflict. Going to go on ad infinitum. Yeah, perhaps. You're in a 970. Come on, Pancake. A 970 is a fine GPU to have. So I'm going to pull the TAWs or the aircraft sufficiently far back so that we give it friggin' enough time to basically stabilize on the new status. So it basically needs to reload the terrain data. It needs to, well, we got to restabilize the INSs here. They're kind of completely all over the place. Close enough. Okay, we got terrain data on. Load it in. So right now, as soon as it gives me an alert, I want to basically start my little timer here.
Terrain.
The timer.
Terrain. Pull up. 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 Pull up.
Okay, and we should get to almost about a minute there before terrain contact. So 20 seconds. Let's see if my assumption holds. 15. 10. Yep, and we're gonna be good. A minute and 2 seconds. That's good. I'm happy with this. Well, not happy to be running into terrain. That'd be very not fun. But avionics is working the way it should. If we go very, very fast, you should give us more warning time, but I'd have to go to some higher terrain. I can't go fast enough here. Good stuff. So Tromso, I didn't forget about it. I think who said that? Bottle Rocketeer or Pancake King, one of you guys said that you've got a test case at Tromso. What's the Tromso Airport IK? Anybody remember? Oh, Pancake's fun facts. You want a chilling read. Fly play and you won't get hurt. Okay. That's a little bit of a long read here on stream, but I'll save it for later. Tromso's ENTC, thank you. Tromso, and let's make it, yeah, sure, about there. Doesn't matter where, we'll just toss the airplane up into the air. Now, which runway would have been the approach? Oh no, they don't have terrain here. Let me actually, yeah. This ain't gonna work. So Tromso is unfortunately out of the question. I did test Aspen, even though it looks like crap. Oh right, I wanted to test, what was it? LEMD? No. Madrid? No. It was Crap, which one was the one with the super curvy approach there? SCEL, no. Anchorage got some fun approaches. So overview. What sort of fun approaches would there be at Anchorage? Crap, not LEPA. No, not that one. There's like a full circle of everything. Madeira, yes. I think. LPMA, yeah. Yes, yeah. That's the one. LPMA, Madeira. Rock and roll. Let's go. And for that one, I do have terrain. Good. Stop airplane. I said stop. Or don't. Gotta get the brakes up and pressurized and everything. I need a... No, I need a... I need to implement chocks. So the airplane starts on chocks. But I haven't gotten to the GUI portions like messing about with stuff. So I gotta get the hydraulics pressurized, then it is all fine. Yeah, those wheels canted off to the side. LPMA to LPMA. I said stop. Off you, and you, and you, and you, and you. What part of use the brakes did you not understand? The fuck. Okay, brakes off. Let's toss the airplane up into the air. Good stuff. Okay, perf gear. And okay, cool stuff. And next, I'm gonna go and RMP Zulu 05. Yeah, Pilum. Direct Pilum. Execute. Actually, just activate the leg from Pilum. Check airport OAT, disable, not that. Disable temperature compensation. Have a fit or anything. What IRS? What happens if you just drop the plane without giving it airspeed first? It just drops. It just falls on the ground. That's all that's gonna happen. Cool. It should probably have set up a cruise altitude here of 10K. Good stuff. That's fine. VNav and go down. And like 4K. And enable that thing. Good stuff. Cool. Do I have terrain on? Yes, I do. Actually, I do. Of course, I do, because I put the peaks display on. And you can of course also select terrain display here on the MFD if you want that. So it's not just the PFD one. In fact, you can have terrain display even with rows format. This is why the rows format has a range indication on it. Good stuff. Actually, I'm going to roll this down to our VNAV constraint there. Since I'm on the approach, I can just arm the approach mode now. 4,800 feet is the highest terrain in the display, 5,900 feet there. It will not, by the way, display terrain that is within 400 feet of your landing runway. So if it's it basically avoids drawing like a platform wherever your nearest runway is. That's kind of by design. Designed to avoid confusing you. Generating a bunch of weird shit on it. So let's have a look at these guys. Yeah, sure. No? Oh, come on. Oh, whatever, close enough. So 5,900 feet, so that means it's more than 2,000 feet above where we are. 41, 53, 59, whatever, close enough. Actually, no, more than 1,000? Yeah, it's more than 1,000 feet above you. It is when it turns red. And we're on path mode. So slow down to 180 for that turn. VGP, good stuff. So it won't stop at 2,000 feet anymore. We can turn on our transponder. Go around altitude is I think 3K here. Yes. So 3K. It's really for that last, half a mile that I'm looking for to the test there. Let's switch this over to present position map. That's a little bit more useful. Slow down some more. We're sort of on a base here. Radio altimeter is alive. The flaps is 30, gear down. Reversers are armed, and yeah, we normally, you know, turn on the APU and do all that good stuff. Not necessary. You'll notice, by the way, when I put the gear back up, the yellow zone here is going to expand, whereas when I put the gear down, well, it's not quite obvious here, but essentially or is it this part here? Hang on. Yeah, okay, no, it's this part here, the low density dotted yellow. So this is driven by your gear selection as well. So when you've got gear selected down, this goes to 250 feet below you, it turns yellow. If you've got gear up 500 feet below you, it goes yellow. So that's what the different versions of the gear shader did. And we'll do a quick approach computation here. Perf approach, 15 degrees at the field. 120, not quite made there, not at all. In fact, it needs an update for the weight here. Approach 130, there we go.
1,000.
There we go, full config. So far, no warnings or squawks or anything. That's good. At least I didn't notice anything.
500.
These are standard calls. Good, good, good. Good stuff.
50. Too low. Flaps.
I think it's 180 here. Speed limited. Oh, 210. If you want some terrain, you can try BIIS. Aviator himself, welcome, welcome. How are you doing? Good stuff. BIIS. That's in Iceland. Oh, Ísafjörður, yeah. I know that one. I can see sort of one direction where it could be sort of marginal. There's one approach that is sort of flying towards terrain and then makes a turn. Ah, right, I think I know what you mean. There, actually, that might be an approach that would require terrain inhibit. Too low flaps. Is okay on a go around. Yeah, I think that was a 4C alert. Mode 4C. I just put the flaps up a little bit too early. I just put the flaps up a bit too early. It's a mode 4B. Yeah, that's a mode 4B alert. That was this guy here. Unsafe terrain clearance with gear down and flaps not landing. So too low flaps as we hit this part here. Less than 245 feet and Yeah, less than 245 feet, and gear down, flaps not landing. That's what we did there. I don't think I don't think there is an inhibit for this automatically. Engaging flaps over, yes, if installed. So yeah, I think this should actually have triggered correctly. And now we just, go around in a circle and everything. Is there anything interesting else here? No. LPMA, yeah, that's the one. We're an opposite approach. No, there isn't actually. RMP visual. Where is that? That one might be interesting. Let's go RMP23. Good stuff. So, depart arrive RNAV 23 via. Is there an? Yeah, let's go via Monac. Execute, and then I'm gonna go ahead and grab the 413 leg. Let's just go direct 413 execute. Good stuff. $5,900 feet maximum terrain elevation in the display range. Ooh, by the way, how I determined that it's not really necessary to be running the OpenGL part of the render on a separate thread. I could have done it, but when I go ahead and disable terrain here, it basically stops drawing that. It even stops the updating on the GPU. It is essentially an immeasurable cost on performance, so basically doesn't do anything. And it's kind of understandable why it doesn't really cost you any frame rate extra to do that, because it's just encoding a couple of command buffers and that's it. I've been careful to make sure that we're being efficient in our use here. You go like this, old school, no HUD. Just go off of what you've got there. Probably more position your display like that, I guess. Calvi. Does Calvi have interesting terrain and nearby approaches? I'm going to assume that it does, since you mentioned them. Or mentioned it. What are you tuned to anyway? VOR Funchal. Oh, right. Well, now, another thing that I've implemented is you could do this. Is it a high on route? VOR. Oh, hang on. I've got the wrong screen selected here. There we go. Yeah, so it's pointing at the VOR there. Currently peaks 0, meaning in the display area here in front of the aircraft, there's nothing that is within range. And there we go, 400 feet. Just about something on the edge there. Just as we're turning inbound. So do I have, so it should give me reset or check out cell. The fun one is circling. So I don't want approaches that are conceivably approach LNAV, RMP arm, good stuff. I don't want to do approaches that are so far, how should I say this, that are so insane that they would require terrain override. Because if they are, you know, in which case if it makes no difference to test the performance of the GPWS, I'm looking for reasonably close approaches to terrain, but not the ones that are so crazy that they'll necessarily have to be inhibited. Go 1,000 feet, BGP, capture. And as you can see, synthetic vision has given us the extended glide slope, or the extended, you know, lead-in center line, so we could literally just follow that if we're completely lost. Line to Luke line, yeah, that one's gonna definitely require a lot of terrain inhibiting. That should be fine. I'm looking at it here on the terrain display.
2,500.
We're turning. We're not going to get very, very close to that terrain, so it should be fine. Six miles. Okay, slow down final approach speed. So that's flaps 30, and we can go ahead and throw down flaps 45. And as soon as it reaches flaps 45 selection, there we get our approach flap config line. Rather, that's the VGP line. So if you go here, you can see what sort of data it's using. So 3 degrees, we can't actually change that. That's not allowed, but we're in baro VNAV, by the way. Glide path mode is barometric at this point. Where you gotta check. This actually does make a difference in the plane, so as you know. Arrival data. So 0.3 nautical mile RMP requirement, and we have 0.3 nautical miles selected.
1,000.
Looking at that ledge here, see if that one's going to cause any issues. And yes, you can see that the nose indicator here is below the horizon. The Challenger is nose low on an approach. And this, I'm basically at, you know, VRF plus 5. If we're exactly at VRF, we would probably have the nose just a little bit over the horizon, but VRF plus 5 to VRF plus 10, you're going to be below horizon. That's pretty normal. In fact, it throws a lot of people off when they transition onto the Challenger.
500.
I want to avoid this radio altimeter when it bumps down. I want to not have it. Okay, it hasn't gone crazy.
100. Terrain, terrain. Terrain, terrain.
Hang on, what was that? That's kind of concerning. It started as soon as the moment I went around. So let's have a look. If I had continued on the approach there, would it have continued to do that? Way. ATS give me speed mode.
1,000.
Make a manual landing here. Hey, the Matium, how are you? 36 Calvi is under 1500 feet AGL. Well, doesn't have RMP. It's fine, it doesn't have to have RMP. Has to have a normal approach. Something that wouldn't expect you to inhibit terrain. A little bit low, there we go, on profile. Just INS here. So, easy way to approach is you basically just want to line this up with the PAPI lights. What are you yelling about? Unequal next altitude, I know.
500.
Okay, I'm actually gonna go at it like this. TALS_alert.c. TALS alert, and I want to basically catch anybody who triggers a TALS alert. And unless it's one of the radio callouts, in which case I don't want to stop it. Easy. In that case, we just want to filter it by the TALS callout type. So break in TALS alerts.c on line 187 if alert is less than that or alert is greater than that one. Good stuff. Hopefully now it will not MRY. Okay, cool. I'll take a look at that one. Okay, somebody wanted to yell at me. Who was it? TAD. What the hell are you yelling about? The fuck is your problem there? TAD should not toss TAD. Which impact point did you predict? 432. TAD caution. I should have turned on debug mode for TAD. Help detect this earlier. At least giving me some sort of an inkling of what's happening. Okay, TALS enunciate, caution, yeah, sure. I have to pull you and reset this test back. And I have to reset the TOS computer. Reads the new status.
Terrain.
Don't be a dickhead. Okay, and I'm gonna pause you if you start yelling at me here. I think it's probably because it's seeing one of these side lobes here as a terrain conflict.
100.
Yep, and so it's seeing the one at 0.175, first impact 0.8 miles. So it's seeing something here. Okay, actually, I wanted to have more info. We should have grabbed the. Should have grabbed. No, brake toss TAD 318.
Correct.
Okay. Beam number 4. And beam number 4 would be 0, 1, 2, 3, 4. So 3 degree off to the right beam is intersecting with terrain. And that's because of this crummy terrain here. TAD, so that's this guy. Not TCF. Terrain alerting and display. So it's this guy here. It's the ribbon style of forward projection where it looks at your predicted flight path. You were in Dubrovnik before. Yes, I was Pilsnerish. It's looking at the predicted flight path and it sees that there is an impact on the. Go to. Do we have the beam data here? No. So 368. Find tau. Oh, never mind. Anyway, so beam number 3, that'll be the one that's 3 degrees off to the right, originating at 0.175 nautical miles to the right. 318. And so the beam base will have been find tau, build points. There we go. And beam step offset. It's this thing here times 2, so it's 0.175 nautical miles to the right. It's intersecting with terrain. And it's essentially the problem is this kind of a bowl that we're descending into. And 0.17 nautical miles is a little bit too far to the right. It's essentially already inside of that mountain, that check. Question is, it doesn't say anything about in the documentation that TAD should be inhibited when you're quarter mile extending out at beam width is starting at a quarter mile, so 1/8 of a mile to the right, 1/8 of a mile to the left, and extending out 3 degrees laterally, more if turning. Yeah, so that's essentially what I've got implemented right now. So it is checking the beam angles that it is checking. So it basically projects like a bunch of beams ahead of the aircraft, and they project out at 0 degrees, -1.5, +1.5, so that 1.5 left, 1.5 right, 3 degrees left, 3 degrees right. And these are just sort of supplementary drawings, so these are not actually used for terrain impact examination. And it's this guy here, 3 degrees to the right, originating at 1/8 of a mile to your right. So it's doing this thing. So here's the aircraft. And so this would be beam number 0 because it's out at 0 degrees. Then there is, let's make this kind of this base here. That is 1/4 nautical mile. And there is one beam here, and they originate at, or they go out at these kinds of angles. So these are 3 degree right beam, -3 degrees, so that'll be 3 degrees to the left. And then there's additional ones here in between, so -1.5 and +1.5. And if it sees a terrain intersection anywhere in those, it then checks for the distance from the aircraft. So it basically then it computes a bunch of test distances. So there is a distance for straight ahead looking. So if you look sideways at the aircraft, so let's say that the aircraft is descending, it projects forward in the descent path down to what they call Well, actually, I think I call it that. So there is the look ahead tau, or time limit. Did I miss the whoop whoop? Reflected reality. Whoop whoop today. The Challenger's TALS is not configured to do whoop whoops, but there'll be more. Don't worry about it. So this is the tau for look ahead, or time for look ahead, and the distance here is calculated, you know, basically just your ground speed times the tau value. That's the absolute distance. The vertical the vertical trend down is clamped at the terrain clearance floor, TCF. So when you're flying, essentially, this essentially is to desensitize the thing for train pull up. Plenty of them. Yeah, there will be more. So this is what prevents the thing from getting too sensitive down low near the terrain, near the runway, because their PCF is going to reduce to 0. So essentially always going to be a flat portion. And a few stall warnings. Yes, sir. Especially during wind shear testing. And so this is tau ahead. Then we've got the tau upwards, or climbing tau. So it looks ahead instead of this kind of a shape. And so each along these points, it knows the minimum elevation value for terrain. So if there's anything that pokes through there, that's what it considers a TAD conflict. And so what it's seeing here is just on the very beam to the right, it's spotted something inside of this here probably region. When it's right now we're very, very close to the runway. That means ECF is 0. So it's basically just looking this kind of a way, and even there, it actually knows that we're close to the runway. So it actually adjusts this a little bit higher. It adds about 100 feet to it just to give itself a little bit of buffer. And there's still something poking through here next to the runway. So I think it's one of these pieces here. Question is, how do we resolve that? Perhaps I should be pulling in that. And when you're down below 30 feet, it actually disables all the cautions. So, and see, it will have shut up. So that's all fine now. But the problem is, we want to get rid of them. We don't want them to. We don't want to yell at you when you're very close down to the runway.
Terrain, pull up.
Oh, come on, airplane. I hate this. Get up there. Anyway, so what I'm thinking, what I could do is I could clamp the lateral. Being yelled at all the way down at 30 feet would be bad. Well, I mean, that's what would happen, right? At 30 feet, it thinks that you're on the ground, so at that point, it no longer yells at you. So what I'm thinking is we could look at the ring clearance floor and pull the beams in when you're very, very close to the runway. Let's see. 80 built points. There we go. Offset. So we'll call this the beam base. I'm going to start pulling it in when you're you see there's something about envelope modulation where specific airports have different envelopes to allow for unique terrain issues. Yeah, that's the problem, is I don't have that data. That's proprietary to them. Actually, I want to grab you as well. Sounds like a massive headache. Yeah. So beam base, and so when we get very close to the runway, we can start pulling that distance in. So what I'm gonna do here, actually I'm gonna grab this and I'm gonna modulate it down when we get to within a certain distance of the runway. So I'm just gonna leave it like that. And if pause state distance to nearest distance to threshold. Oh, hang on. Yeah, that'll do, I guess. What did I call it? Pause and pull. Where are you? Distance to threshold, runway length. Yeah, sure. This will do. Or, hang on. No, better. I'll do one better. So it's gonna go in here into the TAD mode. TAD mode, caution, warning, impact, float. Oh, it's TCF, RFCF. Yes, that's the one. Right, and runway distance. I'm gonna use this here in TCF, RFCF. So if TCF, RFCF, runway distance is not nan, then we're gonna modulate this beam base here. We're gonna weight average it between that and that and iterate it as a fraction. This here as a fraction of nautical mile to meter. Approaches are close to trigger and TOLs but don't require proactive inhibit. I'm gonna go and modulate you down at, yeah, between 0.25 and 1. Clamp the value, and so at 1 mile or further out, you're gonna get the full width of the beam displacement space. Otherwise, when you get to less than a quarter mile, we're gonna basically start looking at it just from your position. Yep. Okay, and TCF, RFCF. Okay. Runway distance. We do compute it somewhere here. Nearest RFCF destination. Not quite. It's in here. Compute TCF. Envelope bias factor. High position integrity. TCF envelope. Runway length bias factor. Where the hell is my distance to runway? Runway length. Runway threshold. Okay, no, hang on. Right, compute TCF. Uh-huh. Hang on, where the hell am I computing it actually? RFCF envelope bias factor. Vector position. Oh, there we go. Aircraft position. Distance. There we go. So this is computed in RFCF, and we are using compute RFCF, airport elevation, runway heading, runway whatever. Okay. Aircraft position. What the hell I use this for? Okay, so here we go. So I just grab this in here. Distance and double distance out. If not, if distance out is not null, then write it back so we can get at it. Compute TCF, and this is using. No, hang on, wait, that's bullshit. Floating point. No, this is all crap. screw this. I'm gonna actually solve it properly, not gonna botch my way into this. So, not that. So it's over gonna be in here in state, nearest threshold, distance to threshold, distance to runway. Distance to runway. Okay, Egypt was. This light tail is very close to a sync rate call. I think let's been like a generated terrain, caution, accept envelope modulation allows for it. Yes, Pilsnerish, that's exactly what that is for. That's exactly what that is for. So where do I update the state parameters here? There we go. State update. Okay. So if we have okay. And let's see. Pause. State nearest distance to runway is going to be Bubkiss. We're going to be actually set up distance to threshold. Nearest airport, blah, 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 blah. Sure. Distance to threshold. Wait a sec, that's port here. Nearest threshold. Distance between my position and not the nearest fucking air. What the hell? No. Nearest airport, and then distance to threshold is, yes, nearest threshold. Okay. So this is going to go in here. Pause. State. Distance to threshold is nan. Distance to threshold. Good. And we also need to construct a projection here. Ortho FPP init. That is going to be at the runway, nearest runway. It's going to be pointing along the nearest runway heading. It's going to be on a spherical projection. We don't need back projection. And FP, so we've already established that. Then we need to go and project the aircraft position. So aircraft position is going to be GO to FPP TOLS in position. On the floor on that. Good stuff. So if aircraft position Y coordinate is less than 0, we are ahead of the threshold. So we're just going to do a straight line towards it. Okay. So that means we're going to go and TOS state distance to runway is going to be vector to absolute value of the aircraft position. Otherwise, if the Y coordinate is less than the runway length, state nearest runway length, that means we're somewhere along the runway. That means our lateral position along the runway is our actual distance to the runway. So it's going to be the absolute value of aircraft position X coordinate. Otherwise, it is the distance to the far point of the runway, which we can get by simple subtraction here. Just doing a subtract of the aircraft position vector with a vector representing the length of the runway. TOS state nearest runway length. So subtract that. That'll give us position from the far end. And just grab the absolute value of that. That will be our distance to the far end. So with that all in hand, go ahead and implement this. And not that. I'm going to look at the distance to runway. And distance to runway. And one more thing. This also needs to reset the distance to runway value. Doesn't have it. Okay, TCF, RFCF. What the hell did I break there? TCF, RFCF, line 69. Okay, I'm going to return you back to the way you were. Line 25, don't need this. Good stuff. Now the airplane's going to be somewhat pissed off because I've... Pilsner's dynamic envelope modulation is the part of what Honeywell does. Is even though they provide you with a terrain database, they also provide you with another piece in there that basically gives you... They've looked at terrain at various airports and they've looked at where it could be a problem. They've proactively put in extra data into the database where it tells the GPWS computer to desensitize certain alerts at some places because it knows that otherwise it would be given spurious alerts. That's basically what envelope modulation is. I can't do that individually per airport. How many RAM do you have? I have 32 gigs of RAM on this thing.
1,000.
My yaw damper on. Could have yelled at me about it if I hadn't. Bit too high.
500.
Now, no yelling. Cool.
50, 40, 30, 20, 10. Take flaps. Take flaps.
Good stuff. Come on, autopilot. Save me. Yeah, sure, something like that. And correctly timed too, yes sir. Could you ever doubt? Yes, all the red out calls are timed such that when the call stops is when it actually does when the actual number comes about. It doesn't just wait for the number to pass. In fact, let me show you. TAWS mode 6. From the hangar now with fresh batch of high-res pictures. Oh, thank you. We're already spoiled. But yeah, that's how this thing does it. Predictive triggering of RAs, and the predictive altitude at which it triggers is blah 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 blah. Update altitude call. So here it looks at the radio altimeter rate. RA next is going to be the rate, or rather it's going to be the current radio altimeter plus the rate down at least 100 feet a minute plus TALS get alert duration, and that looks at the actual call out length. So I have them all timed here to the millisecond. I don't have data for 400 through 200, so unfortunately those are not there. So the other ones are. Oh yeah, you want it. Let me get some funkiness going here with terrain. Have you flown into mountains yet? Close to it, yeah, Clawbot, close to it. Clawed boy, I'm sorry.
$2,500.
Let's go like that or something. That gets us over some terrain. What do we get? Terrain cautions technically, yes, but total pause about a half second from impact. Yeah. Cool. So, let's see when it's going to start yelling at me again.
Terrain, terrain.
There we go, just started the timer. Automatically scaled the display to 10 miles.
Terrain. Terrain, terrain.
So this should have given me 60 seconds. This is about
Terrain.
time
Pull
for
up.
60 seconds.
Pull up. 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 Pull up.
I'm just making sure that we actually do get that amount of time. So yes, this is what I did a little while ago here on StreamGram, so we can see what's happening, or what's been happening. So 50 seconds, 5 seconds, and there's our minute of alert, and boop. Yeah, it's about a half second before impact. So a minute and 3 seconds is about how much warning it gave me. So I'd consider that close enough to a minute. And it also understands when you're going faster. Obviously, it will give you the warning much sooner. It's based on this. It's based on time, not distance. You go up to like, let's go like 5K. I think there's some terrain up at 5K. Yes, there is. So 5,000 should still give us some terrain to run into. This peaks display also was fun to code because all the costly parts of the rendering here are done on GPU using shader code and then transferred back onto CPU. And yep, thank you. This remaining 3 seconds is sufficient. I waited 57 seconds before deciding to act. I don't think 6 more seconds will make too much of a difference. Probably not. I'm basically just trying to make sure that there's at least a minute worth of caution there. Because that's what the book says. That's what the user guide for JIT was talks about it. It talks about that you'll get any arguments from real pilots who've tested this exact function to its fullest extent. That's some pretty dark description, but probably accurate. Okay, so let's go 290 knots. That's about as fast as I can go here. Now the INS is probably a little bit screwed here, yeah, because I've kind of messed about with it. Good stuff. So, and again, we should get terrain auto pop-up here, so it'll, if I was in terrain disabled mode or some other mode, it will also, if I'm on Rose mode, it'll switch me over to P-pause on both PFDs. And down to 10 miles. This guy's already on 10 miles. If I scroll him off a different range, you should be able to see it as soon as it gives the alert. Reset the timer. TCF envelope modulation is activating because I'm close to the runway.
Terrain.
There we go. Add about a second to this thing. So there we go. 10 miles, and both have scaled to 10 miles and P-pause display. Oh, kind of came a little bit early with the... Yeah, it's kind of lumpy here with the terrain, so let's see if the initial estimate was correct. The idea for the whole thing is not to... Oh crap, I'm kind of aiming at a stupid plateau here. So determining whether the timing was correct is going to be a little bit of a difficult estimate because it adds about 100 feet to where it predicts the impact, so it's probably seeing one of these here as the predicted impact point. Or no, hang on, we were probably, yeah, we're over 300 knots, so it basically expanded the envelope here to include extra time. Do I have a piece here that's just sort of lonely and sticking out and everything? Let's have a look. Is there something around here that we can sort of aim at without disturbance from other terrain? Basically want something that is sort of standalone, so I can just measure the timing here. Yeah, this will probably do. Okay, getting ready for some pissed off IRS action right there. Good stuff. Should be a big rock to the southeast. Yeah, well, I'm looking for really kind of a peak. Am I actually aiming at a peak here? Ah, close enough.
Terrain.
So, 7 miles out.
Terrain. Pull up.
Only about 7 seconds of lead time.
Pull up. Pull up. Pull up. Pull up. Pull up. Pull up. Pull
Might
up.
need to change that a little bit.
Pull up.
Give it more lead.
Pull up. Pull up.
Or less.
Pull up.
The warning time. The tau is probably too high.
Pull up. Pull up.
Mm-hmm.
Pull up.
Let's just leave it to yellow a little bit,
Pull up.
get it out of its system.
Pull up. Pull up.
So towel timings, where are you? There you are.
Pull up. Pull
Uh-huh,
up.
uh-huh. Right, I see.
Pull up. Pull up. Pull up.
There, there, and there.
Pull up. Pull up. Pull up. Pull up.
Yeah, okay.
Pull up.
Gotta change the timings here a little bit.
Pull up. Pull up.
How are we looking? Yeah.
Pull
So
up.
about
Pull up.
70 seconds is basically, or more than a minute is what the book says for warnings. Just straight past that boy there. That was just a coincidence. But yeah, we should be good now. Anyway, I'll recompile and reload the new code. VMO 300 of that's 300 below 8,000 Kurigohan. Above 8,000 it's 350. And unfortunately I'm limited to less than 5,000 here because that's what the highest terrain is around here. If I were to go higher, it would not... There's no terrain there. I could go faster, but I couldn't go hit terrain, or aim at terrain anyway. So, INS status.
Terrain.
Yeah,
Terrain. Pull up. Pull up. Pull up. Pull up. Pull up. Pull up. Pull up.
I'm just driving fast.
Pull up. 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 Pull up.
Yeah, about 70 seconds or something.
Pull up. Pull.
130 feet from radio altimeter. And by the way, the radio altimeter has some delay on it as well, so you're about as close as we could get. Oh, I know what. And Kurigohan, to show you that it can go faster, you just have to kind of let it. I go and drag the airplane up to let's say 9,000 feet. You'll see VMO goes away. And you go faster. Up to 350 or 40 or whatever. I forget the number. Not that you want to fly that way, by the way, because it gets insanely loud inside. The INSs are really unhappy here. I have to just kind of get it to... There we go. There you go. 350 knots. So, flight level change, full speed brakes. Let's see how steep we can make this puppy go. I'm going to show you what an overspeed looks like. 8,000. 100% overspeed. No drama. Yeah. I mean, what else would you expect to have happen if you suddenly pull the airplane all over the place? There's a way to manually realign it though, yes. Well, through a debug menu here. This here thing. In reality, you would not have that option, of course. Let's see, what was I wanted to check here? Alright. I was looking at why I have ISA plus 10. And yeah, we're using real world atmosphere. Yep, it was hot. $2,500. Let's throw out the speed brake as well for a little bit longer. Just how much air you could give it. I mean, you can just make it not do very well at all. So the flight path vector here is that you see on the screens is a composite of a flight path. The flight path vector is generated by the flight manager computers based off of various flight path vector sources. Primarily, it'll use the INS if it is aligned. If they are not aligned, it'll use the GPS. But GPS path vector is fairly laggy and slow to respond. So to be sure, that's why it prefers the INS vector. If I do a turn here, you'll see, well, in the air, it's reasonably fast responding. You'll see it lags behind a little bit. It's reasonably fast responding. On the ground, when you make sharp turns, that's when it does kind of weird stuff. All right, I wanted to have some flaps out. I'll have a good one. Happen crash. Hope you're gonna have fun with it. Have I showed you? No, I think I've showed you. Yeah, this is your rain predictions. I think you've seen that. Sure. Cool. Graham, you still here? So much fun. I've become best friends with a Boolean operator in Blender. That's good to hear. Let's see. Graham's still here. We can play around with the wind shear system. Whee!
Caution, wind shear.
Why didn't you? Oh, right. We were above 1,500 feet.
Wind shear. Wind shear.
The increasing performance put me above 1,500 feet. So the system is triggered only when you get down below 1,500 feet, obviously. So the initial forward burst kind of. Flying with Arnold. So X-Plane does have a wind shear event. I don't know where they hit it. It used to be available through here in the edit failures thing. There used to be some way to trigger this, or either here or in the instructor station. Blah, somewhere. But I don't know where they removed it. You used to be able to inject the wind shear. in the weather menu. We're here in the iOS. You can set the wave height if you want, but I don't think I've ever seen a wind shear event. But even so, it's still available via data refs here in data ref editor. If you just go and look for rel wind, we just got far enough away from the runway that it's seeing the ground here now. Rel wind shear, you can basically just set that over to 6 and that'll trigger the event immediately. So you'll get a headwind shear or headwind component, and then you get a descending performance shear.
Wind shear. Wind shear.
And 2 seconds later, you'll get autopilot disconnect.
Wind shear. Wind shear. Sink rate.
And the flight director modes are removed as well.
1,000.
Well, thing is, how do you... So wind shear, it can do a lot, but I'm not sure it can detect. METARs do not generally really tell you of wind shear at all. Have to be 6, or can you set the number to... No. So the number there, the 6, is a enum inside of Explain that tells it which type of trigger you are looking for. Because, you know, it's this here enum. So 6 is failed. This would be 5, 4, 3, 2, 1, and 0. So 6 is fail immediately. 5 would be fail after Control F. 4 would be at an exact altitude, and blah, 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 blah. That's what those are. Only larger airports with multiple sensors. Failures world microburst. They call it a microburst? Hell. Ah, okay. Well, in that case, I was looking for the wrong thing. Aha. Indeed. Thank you. I didn't know it was called that. Yep, that's it.
Caution. Wind shear. Wind shear. Wind shear. Wind shear. Wind shear. Wind shear. Wind shear.
Yeah, so this will be a canned wind shear event inside of Explain. But it will respond to... It's not faked in the sense that it's not just trying to... It's not just trying to, you know, look at the data ref and that's the wind shear event that it's looking for. It will react to wind shear that happens just because of the wind. So it's actually looking at your wind component there. So if I go and... I think we tested it at about 20 gusting 50 is we managed, well, let's make it 20 gusting 60. Sure, and like that kind of a heading is where I'm going to roll out on.
Caution. Wind shear. Bank angle. Bank angle.
Yeah, it's a bit unhappy with the way all the terrain, all the nastiness that I'm injecting into the simulator. And I showed this before on stream, but I'll show you again. It's looking at basically this kind of a coefficient table. Looking for the rate of increase of headwind or decrease of headwind and rate of increase or decrease of climb rate. So it's basically looking at the derivative of these values. So as soon as you get into any of these zones, there's a slight delay, a 1.4 second delay, where it has to be inside of that zone for a little bit. So just a quick peek in and then out, it won't actually trigger. It's designed such that you have to actually sit in there for about a second before it'll trigger. And that's basically to allow for pretty severe turbulence on approach while still not generating a wind shear caution, because that would obviously end your approach right there. And we can actually look at the thing operating. I'm just going to do a quick reset of it. Reset of the TOS computer. I showed this before. Over here you can see how well.
Wind shear, wind shear, wind shear.
Okay, well, we just triggered it. Yeah, come on up there.
1,000. Wind shear, wind shear, wind shear.
Yeah, it's at this point with this amount of wind, it's just generating wind shear cautions a lot. And it's always a bit of a fine balancing act between making it too sensitive and making it too dull, essentially, to detect. If you make it too sensitive, then it'll yell at you all the time. If I make it too stiff or too detuned, then it's not going to generate the warning in a timely manner. Timely enough manner for it to matter during a genuine wind shear event. Little casually popping breakers during flight never ceases to entertain. There we go. Briefly in the warning section there. I was actually looking at the headwind component here, not your airspeed. Smooth weather transitions. There we go. Yeah.
Wind shear, wind shear, wind shear.
Just a bunch of decrease in performance. So as you can see, it does actually think about, it does react to wind condition. It doesn't just look for the wind shear event. It does the right thing, so to speak. Kind of how I roll. And just reset the wind here. What?
Wind shear.
Resetting the wind there caused generated my own wind shear event. Suddenly we removed about 30 knots of headwind. Sweet. Cool. You're gonna have 2-3. No, Monac. Closer one, right? Yeah. Cancel 2-3 via Monac. Stuff. Monac direct. Enter. And let's go. Because I'm kind of impatient, I just want to get there. And the next avian, we can assume so. Yep, let's hope so. There are altitude constraints here, so let's go ahead and shoot up to 4K. Dicking around here at a low altitude. Hey, GDJ. GDA Jeb. Alrighty. Moda is 230. Zoom 250. I'm sure I asked this past, but do you already have plans past the CL650 apart from holidays or vacation? Be likely reuse. So there are well, nah, I wouldn't call them plans. They're more like hopes, and they involve quite a lot of code reuse. So definitely, I'm not looking to rewriting the avionics from scratch. I can tell you that much. And but where those are actually going to go, I'm not entirely sure so far. Depends on a lot of factors that are outside of my control currently. So yeah, we'll see. That top of climb there. It's a top of climb, isn't it? Let's go to VNAV setup. 4,000 feet for cruise. Enter. So which one do you think we are in? So it thinks we're currently in cruise mode. Oh, I selected the wrong approach, wrong side. Zulu. No, not that one. Yankee. Yamonak. That's the runway I want to go to. Now it all makes sense. Check altitude select, short, get it down to 2,000. Let the airplane do its thing. What a speed constraint there, interesting. NJC Gaming 44, welcome. 6830. That about matches, so we'll go ahead and resync our land and wait there. Good stuff. V path coming down. I'm not flying in from anywhere to anywhere. It's just testing around at airports, so we're mostly just messing about. There's no specific spots we're going from or towards. Currently, though, we are at La Palma. I'm testing the the JIPWIS implementation of the Challenger here. See how well it performs with those tight turns there on final. Get some flaps out. Some approaches. There we go. VGP. Slow down to 180. Actually, slow down to 160. Get some more flaps out. Flaps 30 coming in. Not blinking at me. A 508. So sequence through the waypoint there. I'm gonna go ahead and select final config here. Get the HUD out. Alright, and gear. Probably that as well. Would have helped. After this landing, I'm going to do a bathroom break, and then we can go ahead and look at some more, well, some stuff that I wanted to implement here. Some of the messages that pop up here. Okay, fully stabilized. What's the minimum there? 490. Should have probably selected something. 490. There we go. Okay, no yelling. GPWS. Looking good so far. So far, so good. No yelling. Minimums, yeah, sure. Or approaching minimums.
500 minimums.
Manual control here. Never mind the fact that the runway is completely crooked. Quality scenery right there. Good stuff. Okay. So, I'm gonna pause here. Everybody, feel free to use the bathroom, and we'll be back in a few minutes. Yeah, SVS doesn't look too happy. Yeah, it isn't. Cool. Back in a few minutes, folks. Yeah, as usual, smoke them if you got them, I guess. Laters. All right, back in the saddle. Get this show back on the road. Actually, for the time being, we're just gonna go and point the camera up into the sky, and we're gonna go mess about here with the code. This guy's gonna go off to the side. Get from the outside. Exterior model. Yeah, there is an exterior model. It's not finished yet. I don't want to be showing it off too much. Hey, Aster. Okay, so what was it? This was, yeah, okay, here we go. So if the impul gives a sneak peek again. So we want to grab some timers here. Timer, old timer, new timer, timer. There, and pause, range mismatch delay. So when the pause range isn't matching, oh yes, please. Okay, so when the range of toss updater or calling me AFD main. So that's got to be in brain input. Yep. Brain input. Brain input. Handle tray input. Good stuff. Mark that surface as dirty. Good. And okay, actually, so delay line init. Do I have a function like that? No, I don't. Okay. AFD, PFD. I'm just going to copy one of these guys. AFD 522E init. This and called again. Toss range mismatch delay. Yeah, it's going to be a second to microseconds. So 2 seconds is going to be the delay between showing that message. Good. And handle terrain input. Okay. And where's our map range? Map range. Not that. Range. On-site data. Nope. Where the hell was it? Map info. Course heading deviation 2 from agenda. No. Gotta be in PFD display data, right? Display data. Gonna be an RNG here somewhere. Range altitude select. Map info, perhaps. Oh, there it is. So terrain image, part of the AFD stuff. Good. So map and dot range. Okay. So if AFD map range, now it's got to be actually a. Okay. So if not a, if a bus is val, AFD toss map range, and the absolute value between these two is greater than 1 nautical mile. In that case, if delay line push AFD toss range mismatch delay, then we want to actually, well, kind of, yeah, we're just going to leave it like that. Otherwise, push immediate false. That'll reset the timer. So when this delay line is delay lines are basically just kind of time delayed flip-flop value or whatever kind of a delay value. And so that lets me show a mismatch of the TOS range to your selected range after a little bit of a timeout. So when we do change the map range, it takes about a second or two for the thing to muddle its all the way through to the TOS computer and then back out again. So that's how we actually are going to make sure we don't show that too early on, too quickly, so that it would just pop up every time you change the range, which would be dumb. TOS range mismatch. Good stuff. Now, what does there was a no ICAST messages, not quite. Nope. That is runway awareness. There we go. Those are the messages I wanted to see here. So we've got terrain failed, terrain not available. Limited by the TOS computer because the estimated navigation electricity blah 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 blah. Okay. PAD and TCF been temporarily inhibited by the TOS computer. Good stuff. Actually, I need to pop these up as well. Terrain range XXX nautical miles. And terrain overlay is selected off. What the hell would that be? How would that manifest? Oh, whatever. Okay, did TOS internal fault or due to the failure of an acquired input? Good stuff. So that is going to appear in that's going to be probably part of the terrain. On their case, it shows up on the top of it. AFD subwind PPAUSE draw flight plan. Okay, AFD draw pause status flags. And we'll pass in the subwind info, and it wants the AFD as well. Draw track indicator, aircraft symbol. Good. TOS status flags. Good. So that's going to go in AFD common here. These are interaction helpers. Flags. Okay, flight plan status flag, range outcell, terrain overlays, and TOS status flags. IRO T, const AFD, and it's going to take the subwind info T. So it knows where to put stuff onto the screen. Shove it over to the back here. Sweet. Always check all your input arguments. Then we're going to go and AFD get dims. We'll get the dimensions for the screen or wherever we're looking at there. Center Y. That's going to give us a notion of where on the screen we're going to be drawing. Center X, center Y. We don't need the radius. And with those in hand, we actually also want to go ahead and get. So what were the error messages? We got terrain failed, terrain not available, terrain range, blah, 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 blah. Okay, good. So I'm going to keep those down here somewhere so I can see them. So terrain fail. TOS internal fault all due to the failure of an acquired input. So that probably would be good status flag from the TOS. So TOS. So TOS is going to need a new set of status flags here. Terrain inop is already there. It was inop. So we're going to use these two to correlate probably to these two. Then the terrain range crap and terrain off. I have no clue what that's supposed to say or what that is for. That's probably over here. Ah, right. It's for the right-hand side there. Good, not a problem. Okay. I'll have a good one then. Reflect Reality Sim, Graham. See you later. Okay, so train fail, train not available. Good stuff. Okay, so well, for the time being, let's just think about the first one. Terrain fail would be if we had AFD. So we'll look at which map symbols first also. So in 32 map sims, and that can be picked up over here. I already have the code for that somewhere. There you are. So based on the display type, we'll pick up the correct set of map symbols that we're going to be displaying based off of. So if map sims is trying to select map sims terrain and not abus is, and we don't have anything coming from the TOS. That'll be input TOS, impl TOS. This is the terrain input. That's the terrain input bus. That's not the one I want to be looking at here. Yeah, yep. That's the one I want to be looking at here. So it's AFD, PFD, TOS, status. So if that status word is invalid, or we're not receiving anything from the TOS, it means it's failed. Or otherwise, if the status word is indicating a question is, would it show forever? Not where the TOS internal fault or due to the failure of the required input. PIDs and operator TOS internal fault. Now, I'm just going to look for this flag here. If ABUS is valid and AFD TOS status, it's AFD EFD status, TOS status terrain inop. No, JIT was inop. Now TAD. TAD is the one that we're looking for there. Really inhibited that task TOS computer. Now I'm gonna make a new status flag for the second one. And we have terrain inop. The hell is JIT was inop? How do I even set that? JIT was inop. TOS test. JIT was inop is set when you're in testing. Okay. Hang on. I need a new status flag here for sure. So TOS status. Call it in test. And that's going to go over here. And for every test stage, pause. Assert. For sure, we're going to be asserting TOS assert TOS status in test. Okay, so when we're in test, terrain fail. Terrain in op. When do we show terrain in op? We don't currently. Good stuff. Means I gotta go fix that. So we actually want to be looking at map symbols there. Not really. Train fail, train not available. I'm gonna make a new status flag here again for terrain NA. Yes, terrain not available. Okay, so if it is saying we do have valid status flag, terrain not available. Okay, yeah. That's gonna go like so, and status. We're gonna go null, and for color, vector 3t color. Yeah, okay. Color is gonna be vector 3t PL21 amber RGB, and status is gonna be terrain not available. Else if this one is set, or this was valid, we have terrain. Let's see. Terrain in op, I think is what I called you. Pause that H. Terrain in op. But it also isn't showing that it is in test. In test, all of these flags do get set. So we'll inhibit the message if we're in test. And it's probably going to be first one to show up there, not the inhibited one, not the less severe one. So else, I'm just going to reduce the brightness. My screen's about to burn my eyes out. So terrain not available, terrain fail. Yeah, okay. Otherwise, if we have range, if a bus is val, and that's going to be in the main part here, map range, and actually, no. Not even going to be looking at that delay line peak at the delay line there for the mismatch ranges. There we go, toss range mismatch delay. AFD toss range mismatch delay. In that case, I want to use a white color message here that says that's going to actually have to be a multi-length message there. String L copy, size off status. Yeah, so string L copy, size off status, and this is going to be an SN print F status, size off status, and that's going to be terrain range 0.0 F NM, and this is val toss AFD toss map range. I'm just going to grab you, convert you over to nautical miles. Good stuff. Okay, so now that we know that if we need to actually show something there, so that's got to be figured out here. So if status is not an empty string, then we actually want to do something about it. Grab that, go away. And I'm gonna make you 0 vector 3. Gonna grab the center point of the screen. Pyro set font size CR, and there's a data size. There we go. That's my and function for that. And we'll also grab the aligned rendering method function for text alignment. This is going to be a centered piece of text, and it's going to show up like, I don't know, call it 25 pixels, maybe 30 pixels higher. It's going to go center X, center Y minus 30. And it's going to show this here string, no background fill, status, good stuff. 439. Oh, wrong file. Hey, F Zamundio. Keep doing that awesome job. Thank you. Okay, delaying the line. It's not PFD, it's AFD. It's not menus either. Okay, and it's an W1150. Okay, const chart, that's definitely not right. 1157, delay line peak. Okay, I see. 1140. Color, oh right, I actually gotta set the color here. Before, Cairo set source RGB, color X, color Y, color Z. Good stuff. Come on, compile a bit faster. Reload. Good stuff. Okay. Get some ground power on here. Okay, and so what was it that I wanted to check here? Get that up. Grab the terrain, good stuff. And so now if we go to excessive range, more than the tiles can display. Terrain range 200 nautical miles, and it's a bit too low, too close to the nose of the aircraft. Bit further up, about 5 pixels higher, where it needs to go, so not a problem. Just make this minus 35. Reload. I'm thinking I might make the delay a little bit shorter. Doesn't need to be that long. And stuff. Wait for the terrain to reappear. Actually, I'm going to get rid of some of the map symbols I had on here. PFD, don't need the high nav aids. Or whatever. Come on, start displaying. So there we go. And now if we go and zoom it up So this is 200 miles. As soon as I go one up, 200. Yep, that's the limit. It's drawing the overshoot arrow for the missed approach back from Madeira. So this is, or what was it? La Palma or whatever. Madeira, I think. Since I'm currently in southern Croatia. Good stuff. Yeah, if we go like this, do a test.
Glide slope. Pull up.
Yeah, that actually we
shear.
want to get
Wind
rid of.
shear. Wind shear. Terrain, terrain. Pull up.
So this is not going to be shown. And so we'll just predicate this on the status work coming from the guy being valid, so we don't have to check it every freaking time. Okay. And the status not being in test. Good stuff, good stuff. Like so. Here, Johan, have a good one. So reload. Train failed, train not available. What would cause a train not available? Well, probably either GPS fail or what the hell ever. Which we can simulate by pulling some breakers. So I remember GPS breaker positions by now by heart. And GPS 1 is over yonder. And with that on, essentially now have a train fail. Make sure we're going to put the breaker back in, require GPS input, be sure that it really is functional. Come on, explain. There we go. Brain is up and running. All good. GPS status up. Yeah, and now if we go and do, we get a crash. Lovely stuff. What? How did you try and render when we don't have a current position? Apparently I didn't check that. Okay, not a problem. TOS terrain.c606. Right. So this guy needs to actually discard that request if there is no position. No, no, hang on. Position is encoded up in here. So this guy must not even try. Render TOS image. How the hell do we get here? We have no current position. Not TOS. Right. So I tried to do something stupid here. How are you? Are you in test? Test started. True. Okay. Why did you command a render request? How the hell did this thing even try to do something? Test has started. Makes no sense. Started. Ah, okay, it's trying to do the height map. Yeah. Render terrain, and it's trying to do the height map, isn't it? Render height. Yep. Okay, so actually do some pre-validation of that. Render request. Terrain render. So assert is valid geo pause 3 render pause. I think that's, or no, hang on, it's position. Okay, so that validates that it is that. Is valid heading rotation. Actually, we just want to check for is nan. Is finite. Yeah, sure. How does it check here? Train render request, train get FPP, and is finite. Yeah, okay, good. Flat plane projection. Where do we get that? Train render get F. Wait a sec. Draw tiles. Okay, yeah. Good. So that's all fine. Gonna check that. And there's also going to be a second order check here. Let's think about this. Right. So it's not going to perform height tests while we're in test status. If is and not is that. There we go. That'll take care of those cases. Reload back into the simulator. Back in the sim we go. Now, one of the neat things about having relatively low terrain amounts available to me is don't take very long to load into the sim. So there we go. Lovely stuff. The entire thing is very confused at this point. So GPS 1 and 2 are pulled. And I go test. To do nothing at all. Well,
Glide slope. Pull up.
huh.
Wind shear. Wind shear. Wind shear. Terrain. Terrain. Pull up.
Terrain range 50 nautical miles. Yeah, it's because it's not doing anything. So we'll probably want to reset this data point. We're not showing any terrain. Yep. Map range. Render map range. Yep. Okay, so don't have any data. Go ahead and dump that value out of there. Render map range. Gonna have to be explain only stuff. So toss terrain render NR. Yes, terrain render and height render. I get reset to nothing. No current position. We basically don't want to be showing this message at all. That's what's going to dump that out of there. Okay, just align the position quickly and let's start drawing terrain shortly. Change range here. Wait for the terrain to start appearing. We do have it selected. There we go. Kill the GPS. And it should not pop up the message about terrain range. Good stuff, because the value has been invalidated on the bus. Terrain 1 and no map range value. Good stuff. If I go and put the GPS back in, let it reacquire. There we go. Good stuff. Come on, relock already. There we go. And peak stat has been sent as well. Good stuff.
Glide slope. Pull up. Wind shear.
By the way, this is the short test. The short GPS test. If you want a longer one, you have to hold that switch for about 2 seconds. So, 2 seconds. And there we go. Now it'll do all of them. All the audio messages. Currently this is status testing.
Wind shear. Wind shear. Wind shear. Terrain. Terrain.
And after it goes, so from here on out it's just audio tests.
Pull up. Terrain.
And this,
Don't sink.
you'll notice it doesn't
Don't sink.
pop up the
Too low.
it was status
Terrain.
anymore.
Too low. Gear.
That means it's just doing the
Too
audio.
low. Flaps. Too low. Terrain. Glide slope. Bank angle. Bank angle.
Approaching minimums.
Could be, yeah.
Minimums. 2,500. 1,000. 500. 100. 50. 40. 30. 20. 10.
Wind shear. Wind shear. Wind shear. Caution. Wind shear. Too low. Terrain. Caution. Terrain. Caution. Terrain. 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 Pull up. Caution. Obstacle. Caution. Obstacle. 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 Pull up.
And there we go. That was all of them. So get rid of this. And actually there's a little data block here that needs to go be put in there. So I'm going to go do that. So get you paused and out of the way. And point at the sky. And let's rock and roll in here. So that's taking care of the map display there, or the status display. And then there's this data block here. So it's sort of a square of blackness that's sort of off to the side. That's got to be done. EDB terrain database. Traffic TA only. This is for traffic display and the traffic mode. This is the type of display and terrain test and or terrain normal stuff. Okay, good stuff. So I'm gonna put that again in here in AFD common. Actually, there was also, it needs to be, gotta put these in. Right, I forgot to put that display status thing for the range, for the rows mode. That needs to be put in there as well. So Mr. AFD subwin rows. And where are we actually status? All right, these actually need to be printed for everything, even for rows mode display. So pause, full screen. And if we are in declutter mode, we're in decluttered, not in decluttered mode, and we'll want to print the status flags for flight plan, and we'll also want to print the status flags for TAWS. Yeah, like that. I should make them appear. Crap, what the hell? Good stuff. That'll make it all appear correctly, hopefully. So let's have a look. If I go LDDU, back to LDDU, no flight plan, good, and it should appear almost correct. So flight plan, AFD common.c, status flags, Pyro set source RGB CL21 white RGB. This must be white, both of them. Question is, should they actually overlay? I'm not entirely sure if it should overlay any text underneath, or if there's a terrain render underneath, if it should place it. The terrain ranging would be different than the map, or it's just transient. It will be if you're zoomed out to more than 200 miles. 200 miles is the max of the display. So right now it's still going to be able to follow me up to 200 miles. So it's 100 miles inner ring, 200 miles outer ring. As soon as I go above that, the terrain will not change ranges anymore. This is up to 600 miles. I think there should be a black background there. It should probably appear underneath the light plan. So that means going in. So that'll be in here. We want to put, instead of null vector 3, this will be 0 vector 3. So there's a black background there. AFD subwin p pause. And this guy's going to go underneath the flight plan. So flight plan status flags. Is it going to go underneath the flight plan? Question. Well, I'm not sure. What the fuck did I... 7.6. Yeah, my browser keeps leaving these dumps here. Seems a little intrusive. That's what the manual shows it as. Can't help it if it shows that. Can't just change the way it draws stuff. I got the GPS. I don't have the GPS pulled anymore. Or I could make it part of the terrain overlay. Yeah, would probably be better. TRWX, change TRWX, render overlays. Yeah, that'll go in there. So not this and not this, but it's gonna go in here. Graphic or terrain. CR, AFD, and the subwin info part. Good stuff. What do you mean? Of course, comments I make there. What a voice indirectly constant design choice is not your implementation. Not sure that message appears in the plane. Well, it sure is in the. Sure is being shown in here. Or does it go for terrain display over 200 miles? Could be. Hang on, what the hell did I break here? That source surface. Source RGB, set font size. Oh, okay, yeah, I know. That is translated to the center of that thing there. Okay, cool. Okay, sure. Oh man, so many messages. Cool. What the hell are you not appearing still? 0 and minus 35. And like, oh, hang on. Negative radius outer and inner. Okay. Okay. Undo that, translate. That'll put us into the center of the screen there. Just a low-res version for now. Okay. No thanks. Cool. Ooh, yeah, that's wrong. Hmm. All right, I gotta fix that. Maps MTR status here. Center X, center Y. Okay, so it even blanks the frame buffer. Okay, but what happens if you go above 200 miles? That's the problem. Your display stops at 200 miles, which is understandable. I mean, that's okay. Or does it just not let you select more than 200 miles on the range when you've got terrain displayed? I can implement the screen blanking. That's pretty easy, honestly. Let's see. What did I want to do here for that? Maybe a slight delay. Okay, so it'll stop you from zooming past 200 nautical miles when you've got terrain displayed. Otherwise, if it will let you zoom further out. What if you're beyond that? We'll just pull you back in. Oh, by the way, I need to change my peaks display system here to go and display with leading zeros and 3 digits. Not a problem. Raw peaks. It's going to be 03.0. Cool. I'm going to take a quick bathroom break. Stand by. Right back again. Okay, so interesting. So it must be some sort of a software version variation or something. Cause good thing the plane don't track how many times the doors open and who opens it. Yeah, that's a good thing. I'm pretty sure. Okay, so would it, if you just enable terrain, would it just pull you back in at 200 miles? I mean, perhaps. A sensible approach, I'm sure. It's just a matter of figuring out which one they used. Well, in that case, easy peasy change. Wait, no, hang on. Question though. That wouldn't make any sense. Well, sorta. Let me check the documentation here again. I bet. Hang on, let me see here. Yeah, you were doing it on the PFD, that's the trick. I bet you that was the difference. So what the hell? PFD draws are completely different. What the? Man, this is confusing. Seems to be no consistency there. Anyway, lovely stuff. By lovely, I mean it makes me absolutely go crazy. I bet it only does it when it's on the PFD. And it only shows that message on the MFD. So here's why I think that is the case. The MFD is basically just slaving the range selection off of whatever you have in the whatever you have on the PFD here. So when the PFD is set to 600 miles, this guy just follows. But when you do this, and then you enable terrain on this guy here, this guy cannot force the other one into 200 miles. So question is, does it limit to a different range? So if I go up to 600 miles here, this guy stays at 200, or what happens? Or does he follow and just pop up this message? That's the thing, is we don't have you. Well, that'd be weird to know. Well, what happens? So question is, what happens if they are mismatched between each other? Turn off brain. Well, in that case, nothing can be set to 600 miles. Because this guy's the master for settings range. Yeah, you can be set to 600 miles. It could be that it can't be, but this guy, I'm pretty sure we've tested this, and 600 miles is a selectable range on here. In fact, I remember screenshots of you showing 600 miles. So, okay. So does that mean that the PFD just sits at a lower range even if you had this selected to 600 miles? In which case, what happens if you have the MFD set to 600 miles and terrain enabled? This is weird. This is very strange. Also, what would happen if I had 600 miles selected on the MFD and I went to do Yes. You need a formal test plan. Yeah, I don't know. We're at this point we're sort of mapping out quirks of the avionics. I mean I can easily make the thing just show up to 200 miles and make the roller the DCP scroll knob for range. Let this guy go over 200. They slave together. Range is always the same on the PFD and the MFD. But we've set this guy to 600. So this guy would also therefore need to go to 600. Right? They're always the same range. Now in that case, this guy can't go to 600, but I've seen you do that. I mean, obviously, when you sent me screenshots of the IFIS, so the underlying, you know, the geopolitical map and everything like that, those are definitely greater range than 300 or 200. In fact, I've got the screenshots here somewhere. Yeah, that thing goes to 300, no problem, for the MFD. And you had weather and lightning selected on there. Can't type as fast as you're thinking. You're on the phone, aren't you? So this is not selected. It's white. Okay. T0. What the hell's T0 there? Oh, tilt. Okay. Ah, stuff. I think that 300 is the max range of the circle, but the geopol. Yes, I know. Yeah, yeah. You're on mobile. So I know that the geopolitical map draws beyond that 300 mile range ring, but question is, does that mean? I'm pretty sure I read that it goes up to 600 miles, but I don't know, maybe not. So that means, well, that would still not answer the question of what happens if you go to 300 miles on here and 200 miles on here. How do they sync up, you know? I'm gonna go do this. And if you said that this guy can't go beyond 200, and I saw you on that video there, you roll it up as far as it'll go, and it's definitely only up to 200. And go higher. Curious. For sure. A bunch of weird stuff is happening. So, first of all, I gotta implement screen buffer clearing here. So let's go to full screen. Go to full screen. Then in here, we're gonna go and when the map range changes, I want to go AFD ample here. And actually, I want to do something better here as well. I got to actually up the data transmission rate. Hang on. We even have room for that in that bus? Oh yeah, I do. Not a problem. So I could go to transmit every probably 4 hertz. So that's going to go in TOS terrain. Now, so in Egypt was Mark 8 and 1 hertz. Terrain image is going to go to 4 hertz. Transmission rate, and what the hell did I dump against a bunch of ass load of crap in there. 442. Okay. And so if the map range changes on here, we want to map range previous. Save that. Okay, good stuff. And handle terrain input. Map range changes. We'll dump out the existing screen buffer. Yep. Cairo surface flush. Okay, so we'll put it in here. So if AFD TOS map range is not equal to AFD TOS map range previous, then we'll dump the data, the buffer, screen buffer. So it's just going to go memset data to 0 and Cairo image surface get stride AFD terrain image, and it's actually going to be TOS image height times the stride. It's going to dump out any screen contents on a range change. Then we're going to save the new range. How frequently are you transmitting the range? Terrain range. Yeah, transmit max. Good stuff. We should notice that almost immediately. Well, sorta. Okay. Sweet. Okay, so if I go and change here. Well, at least now you don't mostly have old data come in there. That's good. Let's see. There's going to be in terrain buffer here, and we are at 900 kilobits per second, so all good. So we got all that fixed up. So I still want to do the side data block here. That one's still got to be done. It's going to be about there. Yeah. A fairly narrow data block. And I think I have the dimensions here. Cool. So I can actually eyeball you off of that thing. The plan map, you're going to shift over the ICAST there. And so the data block needs to appear from about the midway point, and it's about that width. Okay, cool. So there's going to be AFD Void AFD. No. Void AFD draw a data block. I'll just call it map data block. Hire OCR. Const AFD and subwin info TSI. Sweet. And with that in hand, I can go and this. So with the subwindow information is basically the what I call these individual portions of the screen here. So if I have this ICAS in like this, I have two sub windows, the ICAS sub window and then the lower sub window. Doesn't help the fact that this is Collins calls this the window, but whatever. Potato, I guess. Doesn't really matter what we call them. Anyway, so there's a little data block up here. That sits about there. And that guy, I bet you he's gonna come up right up to the edge of that peaks window and then down. Yeah, that would about fit with the display range there. The amount of room we got to play with. Could theoretically make the peaks window a little bit narrower. Let's check what. I think I got the range, got the dimensions about right. They probably got it too far. Do I hang on? No, wrong window. That one. Terrain. Choo-choo train. So if I shift you over like so, you're not quite touching. It's just about clearing it, but probably a bit too close. It's a bit too close, but I can make it a touch narrower, actually. I can chop about 5 pixels off of the left side here. Shove it over to the right a little bit. Okay, so that's in the status, Tal's status. No, it's in the peaks display here. So draw peaks. There's a little window, sub window here being drawn. And we can make you about 5 pixels narrower. And I'm going to shove you over to the right by, yes, I have this thing sort of guesstimated about there. The high letters are going to go like this. High, low, and this thing is going to be out there and there. And the peaks text needs to go about there. That's about halfway. 1182. Actually, yeah, this has got to just fill in the blanks here just to get it to shut up. SI, unused SI, and AFD. Good. Always lovely when you Discord close up of the peaks window. Oh yeah. Ooh, and the text is outlined in the peaks window for some reason. Isn't that fun? Okay, well, that's a difference. I gotta put in peaks and aligned. What did I do? I have a can function for this. Outlined, this, aligned, outlined. Outlined, and it needs a text color. XY RGB. Okay. Color X, color Y, color Z. And that. Aligned, outlined. Good stuff. Reload. I have to think it might be a little bit too... My texture might be a little bit too shallow. It might not... In fact, actually... I can literally count the pixels because the screen is such a close... You did such an extreme close-up there. I can literally count the pixels on there. In fact, I can tell using this... You know, that terrain render there is confusing as all hell. What this leads me to believe is that this is some sort of an artifact of their drawing methodology for the PFD is actually fucked. Just a thought for now. Okay, and so we got outlines on those. Those are good. I bet it's some artifact having to do with their crappy FPGA implementation. This doesn't look like any kind of sensible pattern. I need to think about how to modify my dot pattern there if I want to modify my dot pattern there. Not sure yet. It's a kind of dark blue, really. It isn't quite that. That's fine, not a problem. I can make it a slightly more saturated color. More like a 6 and a 2 and a 1.5 there. Not right now. Soon, but not right now. $55. This is gonna go. Actually, I'm gonna pull you pretty close to the edge of that thing there. In fact, it's right at the top. Okay, select that. 55. Yeah, okay. Translate. That's good. The top of that is fine. I think what I'm going to do is I'm going to just shift you down by that amount. I'm going to shift you down by that amount. I'm going to make the others match. What I'm suspecting is that their rendering of the terrain is probably trying to be a solid yellow color of some sort. It looks like a weird bunch of fuzz on the pixels. I don't know. Hard to be sure. Okay, a little bit closer. What you got there? Good. Anyway, let's have a look at that data block section. Okay, so come out of full screen here, and what we want to be looking at right in down here. That and good stuff. Okay, and do that at it stops, starts around there, plus maybe 10 pixels up. So I know the height of it now, roughly. So it's the plan center full Y full 600 pixels down. And so it's just ever so slightly above that, maybe call it plus 10. So 1024 minus 600 plus 10 is about what it is. So 1024 minus 600 plus 10, call it 430. Cairo, save. Cairo, restore. Cairo, so enum, we'll make this block width is what? Say the block width here is about this. I can derive this from the peaks display. So if the 65 pixels wide, we're displaying at 90% of the outer radius from the center. So that center point is 768 divided by 2 is 384 plus 90% of the outer radius there. And the outer radius on a normal circle there would be rows radius outer is 227. So 588 plus 65. So it's 760 minus 653, 115 pixels wide. Yeah, sure, that does sound reasonable. 115 block height, I said was gonna be 430 pixels. Good stuff. Okay, so now for the guess the entire sub-window scaling part. AFD sub-win PPOS. Now we should get our PPOS render now. EFD sub-window. Do get your, don't get that. But the MFD sub-window for sure does. Yeah. Crap. Anyway, height here. Yeah, we should be able to pass that in. So do I even need this? Oh, not really, but we can keep it there. Sub-win height. Sure. And sub-win height. Haha, fits on a single line. Always a good thing. So if we have the sub-window height, we know the width. The width is always the full screen width, which is 768 pixels. So I can go ahead and translate. Cairo translate CR to the full screen width, which would be what? Which would be 768 minus block width, and then sub-win height, actually call it AFD width. I think I have a symbolic macro for that, AFD width. Yes, I do. Minus block height. Now we are established sitting on the edge of that sub-window block, so I can go ahead and Cairo set source RGB CRPL21 black RGB. Cairo rectangle CR00, and it's going to be block width, block height. So this will mask off anything that's underneath pyro fill, or fill it with black. So draw underlying fill. And now we actually want to start drawing stuff inside of there. So I'm going to actually make those into probably separate functions so that I'm keeping it reasonably generic. Yep. Sorta. They're drawn very differently between this guy and that. That's confusing. Unless they are based off of where that circle starts, no, definitely not. I hate it when Collins does things differently between different screens for no damn good reason at all. Yeah, the windows are vertically positioned completely differently based off what type of screen that they're setting on. Oh crap. Hate you, Collins, for this. Well, sort of fuck, but not all that much. I'm actually just passing a different value when I'm on a PFD. Yeah, that'll do. That'll work. Cool. So, map data. So call you, then do the actual stuff that's got to be on there. So map, well, data block. Draw traf TFC data, or whatever, call you that. CR-AFD. Now this is going to be always inside of the same position inside of that sub window. Static void, IROCR, const AFD. Now this currently doesn't make much sense to you, but it overlay data, but it is going to make sense very soon when you see the output. IRO T const AFD T pointer. Cert CR is not null. And AFD is not null. So this is going to look, first of all, at whatever map symbol. So it needs to pick up the map symbols that you're going to be using. So I'm just going to copy off of this guy here again. So that one actually we do want to keep here. Even 32T map sims and pull that in there. So map sims, good stuff. That controls what sort of display selections are done. For the traffic, I'm just going to leave it for now because I don't have that implemented right now. But for terrain, lightning, and crap, I can actually do that. So terrain, weather, or lightning. So that's going to show up as terrain there. Okay. It's definitely in a bigger font, but it is, yeah, they're leaving space there to let the thing expand probably. Yep. Sometimes I love Collins for being lazy though. That's kind of making a good day for me. So if map sims is map sim tr, if you got traffic terrain enabled, we'll go ahead and make this thing show. Set source RGB PL21 cyan RGB, and do a little bit of guesswork here to sort of home in on our target. 430 pixels up, about 340. Sure. Cairo set font size. Okay, and text aligned. Sure. Text align. Right. Right, hang on. Where do we control MFD sub window? Sub window. Subwin T. We need to know your sub window selection here. So this guy actually needs some more info. He needs this. MFD subwin. Good stuff. Okay, and so actually probably just have it dump that out there. Yeah. If subwin is thanks for the screenshot there, the photo of that relevant portion. So if AFD is not AFD subwin T, that's going to be an AFD impl subwin T. I thought anyway. Where the hell is it? AFD subwin T. And of course, it's defined in EFIS. You're showing the rows, so you're not showing the rows, and you're not showing the plan mode, and you're not showing the 3D map. I'm not sure about graphical weather and TCAS. Those might show this. Anyway, so in that case, we just don't want to be drawing the map blocks. So these are the only supported modes of display. So on the rows, on a plan, or on a 3D map. And the 3D map, I still got to check because that's kind of what I'm leaving off to as the last sort of addition, because it's an optional feature I can cut if I'm running out of time. I know lots of people would love to see the 3D map there, or tinkering around with it for 5 minutes and then they'll turn it off and never turn it on again. It's a pile of crap, basically. Gonna be about 30 there, about 30, 340 there. Okay, and we'll pass in the AFD subwin T subwin. Okay, and we'll call you selected color. And so cell color is subwin is, oh, hang on, subwin is AFD subwin P pause. Or all gonna support that. It is pretty useless. It's just there are very few cases where it actually helps with anything for legibility. Like you can't. There'll be very few cases where you could really reasonably say something was unclear to you before selecting the 3D map, and more clear afterwards. if it is equal to AFD sub WAN plan, then the selected color is gonna be PL21. No, it's gonna be vector 3T PL21 white RGB. Otherwise, the selected color is gonna be cyan RGB. Good. Selected color, blah, 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 blah. And actually you want to also select that font size. And it's going to be again the data size things there. So I'll select the proper font size there. All that crap. And I'm going to say TR/ here. After which it's going to go to PFD font size small. And we're going to show you, this is going to be about near to the edge there. So probably about 100 pixels off to the right. And it's going to be the PL21 white RGB in the small font, and that's going to say TR, it's going to say WEX LX. Yep. So that's for terrain. Then do I want to simplify this or not? Map sim WEX, and their 2D vertical profile display. No, I don't think so. Now that would have been actually useful, somewhat useful. So this is for not lightning and yes lightning. Okay. Then we've also got to show the case where there's nothing being shown. Okay, so instead what I'm going to do here, selected color. Okay, so vector 3T, TR color, WEX color, LX color. Right. So when terrain is selected, TR color is, these are going to be all defaulted to something. D-cell color. D-cell color is going to be just the white one. And we'll TR cell, WEX cell, LX cell, false, false, false. TR color, screw this. TR color is vector 3T, PL21 white RGB. Okay, traffic, weather, lightning. Correct. Hey, Jonesy, how are you doing? I love CL650. Probably just don't. You just come in there and like just mic drop moment. It's freaking useless. If it was, see, the problem is that on the surface, it's sensible because we think that 2 dimensions is good, 3 dimensions is better. But the problem is that the way pilots fly, or how you have your conceptual model of the flight plan, the vertical and lateral profiles are fundamentally treated differently. It's even apparent in the fact that we can seamlessly use different units for distance and altitude without much of any trouble for understandability. So to show you both of these pieces of information at the same time doesn't add anything. It doesn't, to show you that, you're going to be turning right while you need to be descending adds nothing to your understanding. All you care about is how far do I gotta go? Or in terms of altitude, all you care about is how far do you gotta go? You know, how many track miles? It doesn't matter whether you're gonna be heading south, east, or you're gonna be turning a 180. Whatever, you know. You're in the cockpit, you don't have enough mental, I'd say, capacity at that time to start trying to interpret, okay, if I turn around, I'm going to get a tailwind, therefore I'm going to get, you know, reduced climb performance and blah, 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 blah. Nobody thinks about it like that. All they look at it is, it's about the limit of extent of what you can intuitively grasp on the flight deck is about 3 miles to every 1,000 feet. That's about the limit of what you can expect the pilot to be able to process when they're being bumped about by turbulence. Sure, on paper, on the ground, everybody is, you know, Einstein, but when push comes to shove, not so much. Then all of a sudden, everybody is a bumbling idiot. And I say that in the most loving way possible. Cool. Cool stuff. So if terrain is selected and terrain color is the selected color, terrain selected is true. If map sim weather, then the weather color is selected. Otherwise, LX is selected. Now we just fart out all the symbols of sorts. I mean, it's a high stress, high intensity environment where you don't really have time to perform complicated mental tasks. It just doesn't happen. So TR color, font size. CL21 font data size. How about grab it's bottom aligned, not middle. Tell me. TR select. No, we'll do it like this. Go look in my little font manager. Mr. Font Manager that's just an enum. Okay, so TR font. Gotta be PL21 font small. Small and small. Make you part of that group there, just because you're more closely aligned with that crap. Okay, font data size. And it's Wex select. And it's actually not select, it's font. Okay, so Wex font, terrain, or not Wex, terrain font, terrain color, and like that. I'm gonna say terrain, and we switch to another one. I could optimize this. If Wex font is not equal to BR font, then switch, because font switching is a little bit expensive. And LX font is not equal to X font. And switch to the LX font. LX color, LX color, LX color, X color, X color. No mental gymnastics. No, we'll leave the gymnastics in the cockpit to you. You're the local gymnastics expert. Good stuff. Gotta run. I'll have a good time. Good one. Check the scale range tonight at the hangar, but I'm almost positive 300 is the max in all conditions. Okay, cool. And find out what happens with the terrain display there. I'd be worried, or I'd be curious if it like limits your display or something. Cool. Thank you very much. Cool beans. So this now is supposed to say Wex. And then we got LX. LX, and this is gonna be aligned where? Gonna be aligned for the time being. Let's call you 60 and 90. Check it all. Thank you very much. Maybe like that. Sure, whatever. We'll sort of play by ear. 1262. And it needs the subwin info. Okay, and AFD PFD subwindow. AFD PFD subwindow render. Summary, pause, and rows. So here you gotta go ahead and dump me out that data block. That, so CR, AFD, subwindow AFD PFD format, and subwindow height. That one we're gonna say is gonna eyeball it for now. Yeah, because the PFD one is a bit weird. MFD subwindow. And so this guy here gonna go like that. And he's gonna pass in that subwin crap and pass in the height. Lovely stuff. Now let's see it not work. Actually gonna change one thing. I'm gonna make the background a little bit of a different color just so I can see where the hell it is. So instead of being black, I'm gonna make you like, I don't know, 0.3, just so I can see where the hell it sits. Make it lime green. Okay, sorta. Well, it's doing something. Well, we definitely didn't need quite as many pixels on there. It can be smushed together a lot closer. In fact, it's a little bit too wide. The block width is definitely not going to do us 405. And it's going to have to go a lot higher. exactly, so that would be more like 250. Let's try that. I hate it when they don't put nice and consistent displays everywhere. But then again, comes the breaks, I guess, when you're making avionics. Wait, I want to also reposition that piece of text a little bit closer. Okay, so that is pretty much spot on vertically here. And, or is it? No, it isn't. Way too high. Way too high up. Needs to be a lot lower. Okay, so undo this crap. More like maybe 320, but it's gonna be far lower. Have to be far lower anyway. Think about this some more. 110 is a little bit too far. Still, I want to make sure that there's a gap, and also for the individual piece of text here. This guy is good. This guy's about at the correct position. I just make that about 2 pixels narrower. Make you about 105. Yeah, okay. 105, which would make this guy 95. So now he's correctly positioned. This guy's over to the right, to the left too far, so 80. And this guy's probably by a good 20 pixels too far to the left. So, swap it again. And it's a lot closer to what it's supposed to look like. Closer, but not quite spot on. It's very low, actually, in the plan mode. Because I'm comparing this, be a lot lower. So probably that 340 before was about right. Maybe more like even 350. About like that. There is a slight gap between the TR and WEX LX parts, so that is about right. And yeah, changing over to the plan mode does turn off the thing there. It makes it white, so that's just to show you that it's not actually showing terrain at this time. Make it explicit that you understand that that's happening. Also, when we switch between modes here, okay, and the active mode needs to be biggest one, and it needs to be top aligned there. Okay. I'm gonna make a little PR offset, WEX and LX. WEX offset and LX offset, and that is gotta be over minus GR offset. WX offset, X offset. Now, I want to probably move this guy over a little bit further left, so like 78 maybe. 77, about there, and this guy then needs to move 3 pixels to the left. Now, at the same GPU the TBM uses, Agent Josh only for DC service. So the Challenger has an option of having both an AC and a DC GPU, or one or the other. And they serve different functions. They don't do the same thing, basically, is what I'm trying to say here. Traffic, weather, lightning, nothing, traffic. Good stuff. That's taking care of those. Neat. And neat. Cool. I wonder if it's just, you know, from the top of the sub window all the way down. It just dumps it all over the place. It could be, it might not. VR, terrain, and then terrain test. Being currently tested, okay. Raw overlay data. Good. So if we have that, we could just dump out the perspective mode data right now. Or just not. Okay. Or I could make it more efficient here. If I'm currently in that mode, so this will have selected proper font and size. Good. Okay, so in that case, we could question is, would be like 350, maybe like 375. And the terrain mode, so cost char terrain mode. I'll just make you a empty string. If AFD TOS. Can't even see my screen there, so let me swap over to this stuff. So if AFD TOS, AFD impl TOS, what was the, no, it's the AFD PFD TOS is the status word. That is the status word. So if this guy is valid, then we can think about this. So if we are receiving if we are receiving terrain, so if image is valid, so if AFD PFD, now AFD TOS image data valid, we're receiving image data there, and ABUS is val AFD TOS scan position, then we can say, hey, we got terrain. Unless if AFD PFD TOS status is TOS SD in test. In case this says terrain test. Otherwise, it will say, if we don't have terrain data, it'll say terrain off. Yep, that will work. And so this will say down here, %S terrain mode. And so, pause here. reload. Jump in the sim. Agent Josh, sorry about skipping your question, sort of just flying by it, but if you want to know more detail, I can explain, of course. It's more a question of like, do you want to know more about why there are two different GPUs and what those mean? Okay, so that needs to be like 95. I didn't want to ignore you. Basically what I'm trying to say here. I was just kind of in the middle of something, but if you want to know, let me know. Just put it in chat, and I can explain exactly why the Challenger can have two different GPUs. Okay, so terrain off. So this kind of doesn't quite fit the box there. Yeah, that's always a bit of a risk there. Maybe if I shove everything off further to the right there. But no. It's using a smaller font, first of all. Yeah, it's definitely using a smaller font. So, set font size. CL21 font small. Oh, I did. Okay. Well, I just told you that it could have two different GPUs, so I didn't tell you why. But if that satisfies your curiosity, who am I to judge? Now I'm gonna have to shift that peaks display over a little bit to the left there. Just wonder if you were gonna see your orange little cardigan. Yeah, you are. The Jetco is a 28 volt DC GPU, so it only needs, or it's only usable for when you need a DC GPU. Okay, that. Wait, okay, so it's gonna be about there. It's gonna have to fit. Or, hang on, did you already expand this thing? No, I didn't, did I? Where are you? There you are. 110. Right, and this needs to be colored cyan. It's small and 110. Maybe 100. This plus 5 is 82. This plus 5 is 52. And this plus 5 is 100. The Challenger have the ability to be externally cooked or run it just from the ground. Yes, you can. Never heard the term externally cooked, but you run externally pressurized air? Yes, you can. Hopefully, the air that you give it is clean, because there is no low pressure ventilated air mode like on an Airbus. There's only the high pressure air system. So it's all you get, I guess. Good stuff. The external air implemented yet? No, it isn't currently. It will be. Honestly, though, I'm not aware of anybody running. Well, what would be the point, really? It's not like challengers sit around on a ramp for days on end.
Glide slope. Pull up. Wind shear. Wind shear. Wind shear. Terrain. Terrain. Pull up.
Doke. Actually, this needs to go a little bit lower. Notice like 380. Probably more like 385 because there's probably, yeah, there's room for another line in there. Cool. But yeah, the external air would hook up in here. It will come into your 10-stage bleed system. This is how you start your engines and how you run the packs. But I could mash the button here, wouldn't do anything because I don't have pressure in that duct. Yeah, here you see the AP starting. You can see the pressure building up from it. '96, '97. EPU is available. And there we go. Cool air. Pack inlet pressure regulated to 35.5 psi. 39.5, sorry. When on APU bleed. Otherwise, an engine bleed on the ground would be 24. And just one pack is enough to fully ventilate the cabin here. Currently 32 degrees Celsius, but that's going to come down. So, environmental air conditioning unit number 1. Blowing plenty of cold air into the cabin, 3.3 degrees Celsius. And you could see over on cabin environment coming down fast. And there we go, it's starting to adjust. So this left pack is driven off the cockpit temperature sensor, which you can't see here, but the pack can see. That is part of the temperature control system. That's a little controller that has this valve under its fingers, and that guy just then mixes in hot air and cool air from the pack together to select a desired outlet temperature. And that then controls the target temperature up here. Definitely need good AC around here. Yes, sir. And as usual, I do change the color of that air in the aircraft, even around the aircraft. So if I go ahead and select the pack to full cold, this air is going to get very, very blue to simulate that the air is being cooled down very, very much. Okay, let's turn on both packs so we can get there faster. Load up that APU hard. $20 degrees in the cabin, 21 in the back. And it's very apparent if I change the outside air temp. So if I go to like 35 degrees outside, the air outside is very red at this point. Very unpleasant to sit in the aircraft just with no packs or anything. If we make it sort of Las Vegas temperatures, which is about 42 degrees, if I remember right, when I was there. Oh, packs are not having any trouble cooling it off. Alright, that's because we still got heat capacity in the skin of the aircraft. When the skin of the aircraft, what's the fuel burn on the APU? Lots. Well, not all that much more than it was already, but it's fairly high either way. It does affect fuel burn. You can actually see that. You don't even have to go to the debug screen. Now that I finally got this part implemented, you can go to perf menu, just punch perf twice. Easy way to get there. I believe it was 52 degrees Celsius, where that was probably at some point different than when I was there. Go to perf, so push this twice. Actually, no, hang on. If I was in legs, go perf once, twice, or otherwise you can go perf and perf menu. And there, you go to fuel management, next page, and there's your APU fuel burn. And you can observe what happens when you turn off one of the packs. Yeah, a single pack is about, 20 or 30 pounds an hour of fuel. Wibbles 55, welcome, welcome. Which is why I like the touch screen, so it'll be a great module for us VR users. VR touch screens. Yep. So as you can see, fair amount of fuel extra. 130. It depends on the outside air temp, on a bunch of other parameters. So yeah. .500 degrees currently. And I'm currently not running real weather here. It'll be about 20 something degrees out where I'm right now. Expected is to release this year, yes. Coming out of the exhaust. Yeah. You wouldn't want to put your fingers there. That's even hotter when it's very hot outside. So if you make it like that, 50 degrees or something. By the way, is the temperature operating limiter of the aircraft. So yeah, 128, 130 degree air. That's because the input is already at 50 degrees Celsius, so it's about a 70 degree delta, 80 degree delta, but when the intake is hot already. And chances are the packs are not going to be able to maintain the cabin at a very low temperature now. They're trying for about 18 degrees. But as the skin heats up, it's going to get harder and harder for them to keep up as well. Even though I have the packs currently set to full cool, I could theoretically go to full manual and let's see how far we can get it down. I just go and select valves, full cold. Yeah, +8, +9 degrees is about the best they can get out of the cold air outlet now. Whereas before, they didn't have any trouble with it. How difficult was synthetic this to implement? Along with Arnold, about that much. Sorry, about that difficult. I mean, man, I need this plane hopefully soon. Yep. Wibbles 55 this year is the one it's going to be out. For sure. But yeah, as you can see, the skin is heating up pretty good. See the outside air temperature. Actually, it's going to go above ambient temperature because of solar radiation right now, because we're in the sun. And yeah, poor thing is going to run. Right now, it's actually able to go very, very cool in the cabin, 15 degrees, 16 degrees. But yeah, that's what she said. Yeah, when the outside skin of the aircraft heats up, this is basically our current savior for not having too much heat coming into the cabin. But you'll see that this number by conduction is going to come up because of the fact that the skin, as it heats up, it conducts hot heat to the internals. Outside view can't currently show you wibbles. It's not finished yet. Anyway. Cool. Good stuff. Go back and watch the whole stream. It did go. Yeah, I did. Cool. Yeah, that's the amount of fuel burn you get on the APU. Which honestly, even with both packs running, not that much. I was going to delete the VOD. No, don't worry about it. Not that I care all that much about it. Seems rather low. Hang on, all right. Yeah, there we go. That's about the fuel burn. Both packs on. So you'll notice that the fuel burn for the APU went up. Still the engine fan animation until we get to see the light thing. Oh, that old thing. Can you turn synthetic vision off? Of course you can. There you go. Systems mostly complete, just need tuning, or do major systems still need to be developed? Flying with Arnold, its systems are essentially all complete. Avionics are getting there. I'm currently wrapping up the EGPWS or TAWS. Oh, nice, man. Well, glad you like it. And yeah, you can put the HUD away as well, of course. Two thumbs up. Thank you. A lot of thumbs up. Yes, S-Pass not in use. That's something I gotta fix. Let's watch some pretzels for departure. Not that one. Let's see. Runway 11. Yeah, sure. 2 Foxtrot or 4 Charlie or whichever one was the weird one. That was reasonably weird. Now these guys were the weird ones. Yeah, those are the pretzely ones. Tangled up pretzels. Hey, Ground Flyer. How are you doing? That's the XP aircraft module bar. Thank you, Ground Flyer 69. Doing well myself. Any other business jets to recommend while waiting for this one? I'm not sure. You want something that's in the default G1000? You could go and grab the Phenom from Airbus. Not much else out there that compares to Challenger, unfortunately. Yeah. FD data is the last piece here that sort of is missing. If you want something you learn, you Coronado. Probably Cajun Josh for learning, probably more like the Zebo 7.3. So yes, Zebo's is not a Collins FMS, but it's reasonably close enough that you can get actually familiar with it. Got the Phenom and I don't really like it. I mean, yeah, it's somewhat lower complexity. I want to like the Phenom, but it's so twitchy. Really? Yeah, I mean, the thing's got some other troubles in there as well. Ready for MFD spaghetti? Yes. Yeah, these were fun to fly. Fun to test. And it's frame rate friendly. Is that the politically correct way of saying it's crap? After you're decoding fun times, back to flying. I don't know. Should we do some sort of a fun one? Just a quick end of stream flight, because I want to be wrapping it up here soon. Something that is going to get us, I don't know, let's see. LED actually might be interesting. Bit too far. Oh, with a bathroom break, I think we can swing this one. How about it? Go to Innsbruck. So, tomatoes. This is free ride airspace, isn't it? Or whatever, we'll just punch something in. Armix. Pattern work in the Challenger. We could, I guess, if you want it. Or to stay outside of Italian airspace. Go to Insel. And something like that. That one. That doesn't quite keep us clear of Italian airspace with their stupid rules there, but go gimmicks. Yeah. One of these days we'll get that pank action. Oh, I'm sure you are. So this should more or less keep us clear. Okay. And final thing, just a quick piece of flight plan in here, folks. Stand by, we'll get there in a sec. So RNP, we'll fly with real weather. How about that? So let's go and match real world conditions. Actually, would they be taken off from this side? 3 to 120. Yeah, they would. Okay. I had to bounce earlier. You're still streaming. Yeah. Isn't that fun? Yeah, we'll grab an RMP from Rattenberg. No. Is there anything a little bit more straight? Apparently not. What about a star? Reno. Elmham. Rattenberg, no. Screw those, and I think Nanit and there. That'll do. Perfect. Good stuff. Okay, I got the plan sort of hammered out. So we'll keep this thing. Go to Lowy. Enter 424. Flight plan. So what did I plan for the flight plan? So Matos, then Mali, it's going to be a whole bunch of directs. Or is it? Index. Are we in a current database? More or less. Yeah, we are. Yes, we are on a current database. So what the hell did I screw up here? Can the CL650 shoot an RMPAR? Yes, it can. Mali, what the hell do you not... Why do you not know Mali? Weird. Okay. Darza, does it know that one? Yes, it does. The hell is this then? What about Bamro? Does know that one. Well, Bammer it is then. Darza. GMX. Nanit. Enter, and for the arrival, let's go ahead and leave that one unselected. We'll select it on the way. Any updates on the FMC graphics reader you were talking about? CD graphics. Well, not yet. My brain starts melting up after about a 1 hour Toto stream. I can tell you that it's not currently done yet. So it'll come, don't worry. I'm just going to leave this blue for now. It should be black, but who cares? Okay, we'll just start up the engines here, all casual like on the runway. You know, as you do. So, you guys wanted audio, I think, didn't you? Give you audio. Okay, and make this closer. There we go. Rock and roll. We got some wind even. Our engines are rotating around in the breeze there. Stuff. Let's see, that one. Just hop over here to the other side. Spinny boys. Yes, sir. Didn't quite catch there. Yoke ends on bus. I'll use the AP for bleed. Probes on, got some lights on. Those are all good, good, good. Rock and roll. Well. And reversers, steering. And transponder. A transponder. Alrighty. Takeoff mode. And we should actually, one more thing. Before we actually go. Today we'll just be ferrying fuel, who cares. It's a 400-mile trip, so flight level is going to the west. 360. Execute. And now we've got performance estimates. 1 hour, 8 minutes. Let's go. Oh, one more thing. We should actually compute some takeoff speeds here. So, GNSS. What's the outsider here today? So this is 25. Got your B speeds, yes sir. 25. Send those over. Why are you saying GNSS reverted? Yeah. Ever wonder why the hell it says GNSS reverted on the right hand side and not on the left hand side? Well, it's because Toto was still playing with breakers. Gotta put in the right hand side GPS receiver. So we got V speeds, VR121. Set the target speed up to 200. Clear ourselves up to 5K. And there we go, message cleared, because that means it's got itself all sorted out. I'm gonna give it more about 6 units of trim. And let's go. By the way, it's still on the fuel management here, it still counts our fuel used, so those are all being totalized. And it'll tell us after the flight. Cool. HUD takeoff, no HUD takeoff. You tell me. So, no HUD? Just, you know, conventional screens? Or are we gonna HUD? No HUD. This has been discussed before. Has there been any mention of how we can balance fuel loading is going to be accomplished? Ocean tsunami hasn't been discussed yet. I've got some ideas there. Conventional. Well, rock and roll. I don't need quite as much of the map there. Good. Let's go. No eyes takeoff. Well, I still do want to keep my eyes. I'm gonna arm LNAV and VNAV. Let's go. Hang on. Wait. Oh, right. I've still got parking brake on. I was wondering why I wasn't moving. Okie doke. Captain, our center line is being this laughable. Go 80 knots. Rotate. Positive rate. Yeah. Now go. Give me that flight level change. And since I'm a lazy bastard, I'm just gonna autopilot the screen, the damn thing. Are there actually speed constraints on this procedure? No, there aren't. Above target speed +5. We can go ahead and put the flaps back in. And let's accelerate up to about 210. We don't need to go very fast here. It is a Pretzely departure, after all. Ooh, it's doing something weird there. Thinks it's gonna do something weird anyway. Huh. What's up with that? And keep climbing. I think I know what the problem there is. Now let's look at this. Just maybe have a fuselage with off center lines start barking at me on a 150-foot wide runway at 42. Yeah, it's not cool. Thinks that is there supposed to be right? No, it's definitely not right. Let's just leave it to fly, whatever it wants to do, then we'll figure out if it's a problem with just rendering or actual performance. Standard pressure. Probably have the proper QNH selected anyway. The buzzsaw is more noticeable in the cabin. Could we get a demo of that sound? Yes. Especially in the lab here. Like a rocket. Yeah, I've got basically... Alright, we should transition our packs over onto engines. Yeah, I don't take flying advice from engines to climb power. Yeah, they would have done already. They're already there. The climb performance table ends at 10,000 and 15,000 feet, so it just already did it. And we're more or less facing the right way we want to go. Weird that it's... I'm going to have to check why it's... Very coded constraint for a right turn after. Actually there. Weird. Since we're facing about the right direction, let's go ahead and resume climb VNAV speed. And in fact, what I wanted to do here is go to VNAV setup and climb a lot faster. And we can also drop down to about 300 knots. More or less. The animate button, one of those touches just adds so much to the immersion in my mind. Yeah, same for me. Okay, that's weird. It wants to do a right turn there. Passing over the airport there. We can shove this guy over to Prague here. How's the volume there? Ooh, loud. Taking the volume down a little bit so it doesn't blow your ears out. A real pause, just let the FMS do what it wants, and you shouldn't manually intervene if it's going off the intended flight path. Yeah, I know. Stupid me. If I was a real VATSIM pilot, we should be able to swing actually flight level 380. How about it? Go perf. Got a VNAV setup, and we can go ahead and shut off flight level 380. Execute. Roll you up. I forgot Forgot to turn on my green banana there. So that's over here. Range to altitude pre-selected. There's LRC and max cruise pre-calculated. Yes, they're table-based. It was one of the things that I still got to implement. I forgot about it. Where are you? Per cruise. Still got to fix this. So LRC and max cruise are coming off the performance tables. Getting into some turbulence here. Most of the time. It's still trying. Yeah, you can see. Never mind, those two dots is a bit of straight geometry. That's going to get fixed. A mere 2,000, yeah. Well, wait until it gets to flight level 336, where it's going to get sort of a second life as it switches to Mach mode. Well, it's probably going to switch earlier than that. Or later? I don't know. Right now we're in FMS speed control, so it might actually switch at a different speed. Yeah, I'm going to get about 200 miles of cruise out of this. Okay, yeah, other than that, there's really nothing left to do. Didn't even turn on the lights here. Actually, I could just turn on turbulence mode. Soften it up even more. I'm going to be fairly lethargic at this point. Or trying to correct. Anyway, you can see at high speeds or high altitudes, the performance ain't exactly the best. He's had better days. There we go, Mach mode. And now it'll maybe get another 300 foot per minute out of that when it switches over. And yes, of course, it continuously recomputes based on performance where things that are top of climb is going to be. Ouch. Everything's getting worse. I don't have my weather plugin in the sim, so whatever we get is what we get. How well the anti-skid will deal with gravel runway. I'll try that when it releases. Probably not very well. But you're not going to get much braking, essentially. Temperature-wise, what's it like outside? Still ISO +1. We're going to get up to about there, so we're pretty close to ISO conditions most of the way. Finally got the window resizing scaler, uniform scaler put in there. Got about 35 miles to Bamro. Hopefully with the high mounted engines I can hammer the reversers to make up for the lack of brakes. I mean, you can. The reversers still do, they still can hit the ground underneath you, so they might still be kicking up pebbles. And even though they might not ingest them, well, the underside of your jet, your beautiful biz jet, ain't gonna look so hot. And that, of course, I mean, it's gonna look beat up to hell. VOR1. What did you tune to? SPL. Apparently. Want to tune VOR? Yes, that's what it's set to right now. Don't worry about it, Steel 737. Welcome. All is well. At this point, we just watch the world pass by. There's our little standby pitot tube here is getting the air hammered into it. What was that page with high-low sensitivity? Second tune page. That's your radio control page. So if you click on the on respective radio, you can enter. Well, it's only for nav and comm. Should be a second set of radios here on second page, which you still got to do HF radios. Comm 3 can do the same as well. Let's see. So what these do is, oh right, I forgot about TCAS. You can also set. I forget everything that this thing can do. This is a thing I coded a long time ago. Anyway, what this does is it lets you control various settings about that radio. So marker sensitivity, whether you want to have DME hold enabled or not, whether you want to go to manual or automatic tuning, you can do a radio test. And then you got your pages and pages of presets. If you care to DME hold, yes. Never heard of that? Never heard of it. Now, DME hold is a feature that lets you decouple. So the Challenger has how am I gonna describe the architecture here? The DME radios there are two DME radios to be exact. First of all, basic definitions out of the way. A DME radio is very different from a VOR. They are not Even though they're frequently co-located at the same facility, they use completely different signaling, and the radios are not at all the same unit. Some systems do have them integrated, not the Challenger. So, and doing a gentle turn to the right. And there we go. Well, minus the turbulence, but whatever. So they are two completely different radio architectures. So the way that it usually works on most systems is the DME radio is what they call coupled or tied, sometimes called slaved, to the nav radio, to your VOR/ILS radio. And the reason is that although the DME operates on a completely different frequency, it operates at about 950 megahertz, between 900 and 1,000 megahertz, whereas your VORs sit down at about 110 to 120. For simplicity, ICAO has designed them in such a way that the DME channels are always corresponding one-to-one to VOR mapping. So there's a table published by ICAO, I forgot which annex, might be Annex 10, which basically tells you all the frequencies that are standard for VORs and then all the matching channel frequencies for DMEs. So theoretically, what you can do is you can basically just map them one-to-one, or you can just call DME channels by the same name as VOR frequencies. So even though the DME right now it says it's tuned to 115.7, it actually isn't. It's tuned to something much higher, but it's paired to the 115.7 channel, or 115.7 VOR. But since the DME itself normally has no separate tuning functionality, it doesn't have a separate, tuning control in the cockpit, because you usually want to have them tuned at the same time. Again, caveat being usually. You just have to punch in one frequency in here, and that automatically tunes both the DME and your VOR. And I can show you that, because on here, we can actually go into... Did I show you here? Not quite, so it won't show quite that easily. So let's go like this. In the Challenger, you can actually look at the DME data output buses, and these are the frequency echoes coming from the DME radio. So right now, it says it's tuned to 116 megahertz, quote unquote tuned to megahertz. It really isn't. It's tuned to something much higher, but it's tuned to something like that, or close to it. And same thing when I give the tuning back to the computer, to the FMC, you'll see that the DME here retunes to the same frequency as the VOR. But what if you wanted to have a different frequency in there, right? So there are procedures in the world where having the DME and the VOR tuned to a different frequency might be useful. It's usually cases where there's not too many navs around, so they'll have you tune the VOR radio to follow a path or a localizer or something like that, but there is no DME station at your target, so they'll tell you, use this frequency for your nav and use a different frequency to read your distance off of a known point. They'll provide check distances against that other DME. So in those cases, what this lets you do is it lets you, if you push this, now you have decoupled the DME from the VOR frequency. So I can now, I go to something that's, let's say, right now we are tuned to SPL on both radios, right? And if I have a look over on here, you'll see it reads 16 miles. But I don't have to, because I've decoupled the thing. I can go and let's say this is a VOR DME, so it does have a DME component. I can go 117.35, push that in there, and I don't get a distance reading, probably too far or something's off there. 106, 108.60. Why aren't you showing me that? Is it because I'm filtering it when it's not showing the same frequency? I need to check this. No, the DME is receiving, so it sees the distance. It's just not being displayed on here while I'm in nav mode, in FMC mode. Okay, no problem. I'm going to heading hold. We'll switch your nav source over to VOR. Yeah, there we go. So right now we've got VOR 1157 tuned in SPL identifier, but I've got a different DME tuned in. And let's pick something that's ahead of us. Something like this. 11790. 11790. And you'll see we got 68.3 nautical miles to that DME, which is a completely different direction. So even though I'm flying away, you can see I've got the from flag here. I'm flying away from that SPL VOR, but my DME is decreasing. That's because my DME is not coming off of that same station, and that's something I have to be aware of. It is abundantly obvious. If I look on my radio tuning panel here, you'll see that it says 11790H for hold, as in when I tune this, the DME is held wherever it is tuned to right now. That's what the hold part there means. If I go and bring up, I can also tune radios off of here. So if I go and mess about with this radio now, oh, something I broke? Oh yeah, something I broke. Lovely stuff. Well, let's tune just over here. Oh, hang on, I didn't. It should have disabled auto-tuning mode. Yeah, that's why. Got a manual tuning, that's why the friggin' thing didn't want to let me tune. Okay. Let's try that again. So now I can swap that frequency over, but the DME stays at the same one. Let's put out DME. Yep. One VOR DME that is now just a DME, and one has to use DME station for the approach. Yes, exactly. As Pilsner says, we frequently repurposed old devices, or when there's sort of a mixture. Anyway, that's kind of the deal there. And if I go and re-enable automatic tuning, and I can also do that and bring this up. By the way, this radio control menu here, you can actually do all the same settings via the MFD here. If you go to roll this over to the nav1 box, push radio, and it'll give you most of the reasonable settings out of that window. So you can manually select the DME hold, or you can switch the marker sensitivity, and you can even have a quick access button here for DME holding. So I can re-enable and disable it. And same thing here. I also have some frequency settings here, mode and everything. And I finally also have ADF does. Oh yeah, ADF also has some settings in it. PCAS has a lot of settings in here. So you can select your above, below, whatever mode. Anyway, switch back over to nav mode FMS. Yeah, we didn't stray too far. Yeah, let's go back to LNAV. And our top of descent is over there at Gimmicks. Yeah, it's just ahead of Gimmicks. And that's why it says, if you look over here on VNav, it says predicted Gimmicks level 379. Now, currently we're missing the rest of our route here, right? So we've got Rattenberg and some other places. So to tidy that up, I'm gonna go into Lowy arrival. And what's the arrival that I want to do there? I only have one picked out. That might actually change our plan. So watch this. Right now it predicts 34.2 thousand pounds gross weight there. But as soon as I put in an arrival, it's probably going to change a little bit. So Nanit 2 Alpha. Execute. Not too much. Good stuff. So now it thinks that we'll be, well, it doesn't give me a, we know that after Gimmicks we're going to start to descend somewhere. 15 or above, 3,500, 9,500 or above. What sort of approach are we going to do? How about an RNAV of some sort? Right, somebody wanted, does actually this thing even have RMP AR? It does. RMP AR 26. That's as straight in as it can be. That one's boring. Just gonna need a 616. That one's a little bit less boring, but still fairly boring. Localizer Romeo. Now let's just do a localizer. Sure, why not? Who cares? Now, what's the weather there, by the way? Since I am jibber jabbering here, probably check the weather. Weather at Lowy, variable 1 knot, so it makes no difference. So we'll probably circle. So, localizer 26, we'll circle to 08 for noise abatement and stuff. Localizer DME East, runway unspecified. Yes, sir. Hard arrive. Localizer 26 or which one? There's no localizer east, so just probably localizer 26 or something. From Rattenberg. You up. 3.77 degree descent path. There's a missed approach there, which we're not going to worry about. Rock and roll. Let's say this is about us. I didn't have any trouble parsing the runways. No, it didn't. So, all good. Everybody agreed. Let's see. Does that change our fuel prediction? 100 pounds more. So it expects it will take probably about a minute longer and about 100 pounds more predicted for fuel burn, and actually that pushes our TOD past Gimmicks because we don't have to be descending quite that early to get there. Good stuff. And that's it. Nothing more to it. So while we're still en route, I'm going to just leave this here, bobbing about. I'm going to go and go to the bathroom. See you in a minute. Alrighty. Back in the saddle. Hopefully everything's gonna go smooth from here. Cool beans. Got some flour over there. Not too worried about it though. I can't enable terrain display on my side. Already got terrain on that map though, as well. Yeah, just for testing. If I disable terrain display here, take a while for it to start back up. Fraction of a second, I guess. I presume you all can hear me fine. Let's see, it should do a gentle turn there into that corner. Hey, leading edge, what are you doing? People keep asking me about that external model to show them, and I can't. I'd love to, but I can't. It's not to be a dig if you don't worry about it, though. It's just me sort of trying to find some jibber jabber about. So, there we go. It's only about a 10-degree turn, so it should make it very gentle. There, and that's it. That's about it. 7 degrees at bank. Maybe even less. 5 degrees of bank. Yeah, pretty much. Doing a minimum effort turn here. 34.1 is a predicted fuel. I would have probably refined the fuel prediction if I'd entered what the upper altitude winds are going to be like, but who cares? 0.13 nautical mile cross track. 1 nautical mile cross track. And it's slowly going to start pulling this in just ever so gently. Reminds me, I got to make sure that this diamond isn't filled. It actually is hollow inside of it. Did I return? I didn't return this back to the FMS for tuning, so let's give it back. Urban rotation animation leaked. Well, there you go. It's spinning. By the way, that buzzsaw sound, that is not just something, you know, I kind of botched in there. It still is buzzing if you go back there. If you move about in the cabin, it's going to sort of vary in intensity, but it's still buzzing, even at high altitude. You know why? Anybody want to take a guess? They're not you regulars, guys. You already know. I've already told you, but any of the newcomers here, you want to take a guess why it's buzzing? So he's pulling down 0.02. How are we looking on the navigation and system accuracy here? FMC1. IRs are doing pretty good. No takers. Nobody want to guess why. Well, guess we won't know then. Now 0 feet. Still being in my road. Probably what we see is the grain off to the left there. It's showing peaks 0. Yeah, fan blade RPM, yeah, but why? Why do fans buzz like that? 7.5 hours of streaming so far. Ocean Tsunami, you're very close, yes, and essentially you're right. It's not at the speed of sound. They are above the speed of sound. They are supersonic. Yeah, the engine's fan, a decent portion of it actually is rotating supersonically, locally, from the point of view of the local air in there. And so, make sure I'm not just making up when and why it would do that kind of a buzzsaw. I do actually. What did I call you? Called you something mock. Oh, there we go. Yeah, I remember. So, this is actually in real time being computed from my engine simulation, since I know exactly how large the fan is and how fast it is spinning. From this, I know the local air temperature, and I know the flow velocity. So there's a radial and a tangential component to the velocity of the fan blades relative to the air. And since I know the tangential flow velocity through here, how fast the air is being pumped through the engine, literally as a kind of speed, you can calculate the effective blade tip Mach number. And you'll see that in flight it actually is pretty highly supersonic, 1.34 Mach. And that's not even as fast as it'll go. It'll go up to like 1.6 at the very tips here. Further in it's a little bit less, obviously, and so about a third, the outer third of the fan blade is supersonic from the local air's point of view. That's what gives you that buzz effect. And in fact, most of the flight, the blades are supersonic. Probably, yeah, I mean, I've had a look at it. I think when you go all the way to idle, it might just about barely be subsonic, but essentially throughout the entire climb and cruise, you've got supersonic blade aerodynamics. Cabin pressure is at 8.8, and actually, I gotta check this. Landing field elevation is 1,900 or something. 19 something, basically. That's field elevation there at Innsbruck. 26 minutes to Innsbruck. And it doesn't know that we're going to circle the land, so it doesn't account for that, obviously. But what I could do, what about I'm not going to ask him. Imagine Austin putting his head in there to measure that. Yeah. That wouldn't be very, very smart. I don't think even Austin is that crazy. Yeah, so things to consider. I still gotta fix these fuel predictions. Well, things to consider that lets you do or some of the neat things that a Collins FMS lets you do. You go to perf, VNav, and you go to the final page here. You go to descent info. And what this lets you do is let you quickly look at various distances for descent to get down to various parts of your flight plan. So let's say we want to check how far from present position it would be. And yeah, we go directly to the airport. Oh, hang on, which has to be on the flight plan. Sorry about that. It has to be on the flight plan to be a descent waypoint. Or what was the other one? There's so many features on here, I forgot I even coded them. Arrival data. That just tells me about the arrival. That was under field flight log approach, secondary performance. We're doing approach estimates here. It estimates 34.1. And temperature down there is 15. 126 predicted. Now that was under here, fuel management, trip computer. What this lets you do is let you calculate alternate flight targets. So say for instance, this was the one that I wanted to have a look at, and then the other one. So, all right, specific range to ground speed. Yeah. So this is giving me a bunch of parameters or metrics, I guess, for how my aircraft is performing. Really that? I gotta check. Might be half that. Right. Range to reserve, time to reserve. So it tells me if I want to have 2,000 pounds of reserve fuel, how far or how long can I go at the current consumption rates. Another thing that it lets me compute is if, let's say, I don't want to go, this fast. I want to go at, I don't know. I want to go at a much slower speed, like 400 knots. I can punch that in there. And I can say, how far would I go if I said I burned 1,750 pounds? And it should give me a recomputation of the time, range and time to reserve. I can go back to predicted fuel states. Another thing that I can, so this is my totalizer so far, burned 2,340 pounds. Coming up to a gentle turn to the left here. Now, what I can do is I can do an alternate target. So let's say, at my current speed, 2,000 pounds an hour fuel flow. What if I want to go from present position instead of to direct to Lowy? What if I instead wanted to direct to Salzburg? Or rather, no, let's not go to Salzburg. That's obvious because it's right next to it. What if I want to go to Frankfurt? What if your customer on board says, you know what? Throughout the flight plan, we're not going to Lowy because I just had my call over my satellite internet and I want to go to Frankfurt instead. So you can do a quick computation, or let's say you want to go to Berlin, new one, whatever kind of VDT is tabled. So you can quickly calculate how long it would take and how much burn you would require to get there. You can quickly then compare your present fuel and check for, am I actually going to be able to get there? And so this lets you quickly calculate alternate flight plan scenarios. It's pretty useful on a bizjet. Usually on a airliner, you don't do this because whatever, you're just going to go wherever you schedule your target to be. Or worst case, you're going to go to the alternate fuel. You can actually just go ahead and I have an alternate loaded in here. I'll get a paraffin out in Prague. It would show up in here, which I can do by going to flight plan and punching in an alternate. So let's say, sure, Grouse would be an alternate. So I could easily do that, but what if I want to check, coming up to top of descent here, I'm going to roll down my altitude pre-selector. Top of descent is less than 1 minute away. That roll this down to like 15K, whatever. Let's say that we're cleared all the way down there. And that's it. 5 seconds to top of descent. Here it goes. Path. 3, And you can also see on the HUD, slowly coming down. Okay, there we go. And we're establishing the descent. So, what the fuel management page there lets you do quickly for fuel management and some of the trip computer is it lets you check out, what if we were to go to a different destination from here or from some other place. And that's what that lets you do. And you can also, put in alternate flight speeds and alternate fuel burns. So let's say you were, instead of right now, obviously I'm in a descent, so that's not the correct fuel burn, but what if I was burning 1,900 pounds an hour, which is really correct fuel burn? I could probably BGW, let's say we want to go to Gatwick all the way there, 2,800 pounds of fuel. Yeah, we got that with reserves, so all is fine. We could go to Gatwick if we wanted to. Right now I'm burning nothing, so it says that I've got 2,300 miles of range, but that's obviously bogus because I'm descending. But yeah, nice little BizJet features, I guess you might call them. And still the blades are supersonic. Perhaps if I was to go to hard idle, it'd be subsonic at this point, but not yet. 32,000 coming down, cabin altitude about 400 feet a minute. That's about what it's targeting, between 300 and 400. And it's going to modulate the outflow valves, which are right here. You can see them operating. You can actually see them slowly moving about. These valve seats here are going to slowly modulate. Right now we're in very high altitude mode, so they barely have to move at all. Just fractions of a millimeter are plenty enough to get your vacuum control and everything, pressure control. There we go. Switched over to IAS mode here. There are actually speed restrictions on the arrival there. There isn't. All old stuff, and yet they do. No, it's supersonics. The supersonic blade speeds are not a problem. In fact, they are supersonic even when the aircraft isn't moving. Even when you go to full power on takeoff, you can get them to go supersonic. At the blade tips there. Now they're subsonic probably. We can check. Problem. What I'm hearing is just barely 1.1 Mach, 1.08. Slowly coming down. Both the fan is slowing down, is decelerating. Because we're coming out of a higher altitude down, and also the air is warming up, so that's causing the local airspeed or the speed of sound to go up, because the speed of sound is depending on temperature. So that effectively reduces the inlet Mach number, or the blade tip Mach number. Going to prompt me about temperature compensation. I'm just going to tell it not to do anything today. Execute. Sure. approach ref. Got all of that ready. We can go ahead and send our V speeds over to the PFD and MFD, or sorry, the PFDs. You show them the exterior. No, well, I tried not to. There might have been some glimpses, but I was trying deliberately not to. And again, that's the deal with streaming. Sometimes you kind of like forget, because I'm not used to, tiptoeing around it. When did I put this in? Apparently I did anyway. I'd love to see the exterior. Well, only when the big man says it's okay. And also I'd like to see some landing gear in there. But it's still got a little ways to go, but it's fairly close. Give him a look. Okay. Here's your look. There. Awesome look, wasn't there? Wasn't that? How about this one? Coming up to Nanit. Probably gonna be about, we're gonna be higher than 15K. Adult Challenger 300. Yeah. 300, that's had a couple extra biscuits. So QNH 1024. What is the transition altitude there usually? You see that perhaps, guess it from the SIDS. SID. 10K. It's high pressure, so probably 10K is gonna be not that big. It's got stripes and spinny turbines, definitely gone by. Having issues animating after unusual animation. Starting to texture and landing this morning. Yep. Oh yeah, those flaps are testing your patience, I'm sure. So 1024. What am I doing here? No, not that. That 1024, and we're on the right 1024. There will be a standby instrument here. Eventually. Could you explain what path you used to generate 3D terrain used for the synthetic version? Pilot Pro, it's complicated, but yeah, that'd be a fair trip to explain all of it. So I'm not even gonna try for the time being. Eventually I will. Does it rely on terrain database, or does it generate based off of something else? It's a terrain database, yes, but the terrain database is dynamically read from your X-Plane installation. It is not using the X-Plane probe API. Rather, it's using the underlying data files directly to generate, to essentially serve as the database for it. Let's come down to 9500. To effectively serve as the terrain database. That way it is always up to date, so to speak. So there's nothing I'd need to ship to you to get your terrain data up and good and running. Wherever you have terrain in X-Plane, you're going to have terrain in the synthetic vision. In fact, you probably are going to have I think the Earth orbit textures of X-Plane don't quite go above 70 degrees north latitude, so over the poles it might be water. I think they go up to Svalbard. That's about it. So getting into the deceleration phase here. So the thing is starting to pull back on the speed. Want to be 95 or above at Rattenberg. It's an overfly, interesting. Probably coming in way too fast, so pull all the way to idle. Oh, it should have been a dashed line there, buddy. I gotta check why it's doing that. So anyway, now we're in the approach, so approach localizer. Low pre-tune should be that. What happened to my pretty pattern there? Probably should have put a restriction there because it thinks it can go up to 300 knots down to. I'll be more interested in it. I'll be more than interested if you get this one day, as it would help me in my learning C++. Any comments on Austin's T's and new XP? Good stuff. I'd like to see more. Cautiously optimistic, as they say. Start decelerating even more. Rock and roll. So now we deselect glide slope because this is a localizer only approach. And in fact, I'm going to go and turbulence is deselected. Good stuff. Come down. There should be check altitudes everywhere, and I'm such a poor pilot. I'm just gonna go ahead and dive bomb it on down. Just select this, go to BS, and roll you down there. So there should be a bunch of preset, check altitudes, and we are high as a friggin' kite. So slow down. I'm implementing a completely new icing model. He wrote a poem on it a couple of days ago. Cool. I'm looking forward to it. Switch over there. Okay, 15 miles, 7,900, so we're about 1,000 feet high. But we'll slow down there. Not too worried about it. 3,600 is the breakoff for the visual circle, I think. VNAV off. $13 miles is 7,100. We're getting there. These have really got my attention. Yep. What do you mean? What do you mean, the lighting? Or was there some other... Into the soup we go. Or is there some other teaser? I'm kind of out of the loop. You know me. Yeah, 180 knots. We're going to be coming down at 1,200 feet a minute. Rock and roll. I've learned some things about how icing affects aircrafts. I'm sure he has. Here's our TAWS display. Actually, it's giving me a lead on line onto the runway, but we're gonna do the circle. Since it is variable weather, I would assume that they'd want us over on the side there. Visual road circling. 3,700. Sorry, not 36. 3,700. About a 230 heading. Good stuff. $160 knots should be about doing about 1,100 feet a minute. Yep, noted. Oh, come on, the weather should be better than this. This cab okay. Broken at 5,000. Calm the hell on. Explain, what the fuck is your weather?
2,500.
There we go. Got the runway in sight. 5.5 miles. I forgot to look at my check altitudes. Who cares? Altitude select cap. We're below the cloud here. So let's go ahead and circle. You could do it with way more assistance if you wanted to, but whatever. It should be weather should be broken 5,000. This ain't broken 5,000, dude. This is 1,000 feet lower. Well, HUD time. We would be tuning in the localizer here. Got a DME reading. Already got that in. And if you were a good pilot, you would go in OEV, and you would get a distance crossing circle 3.5 there. That's fine. No intersection with the flight path here. It doesn't matter. And so that's our little circle there. 364 for the next one. I'm just going to leave it at 160 here.
1,000.
Final speed is 120 something. At 126, so we'll make our final speed 130. Flaps 45. And now we will be looking for that 3.5 mile turn back. I'm kind of curious if the TAWS is going to yell at me here. It might not. Lowy. Yes, sir. So I basically slowed down to my final approach speed here to make sure I got plenty of time for Oz not to freak out. Go over to that kind of a display there. Range is a little bit annoying, so I'm gonna get rid of it. I'll leave it on here. And there's 3.5.
Terrain, terrain.
Light director off. There's our ridge. We're gonna get a nice 3-degree descent path there. The prediction.
Terrain, terrain. Terrain, terrain.
There we go. If only I had a co-pilot push the button. Thank you, Matthew. Very much appreciate that help. Didn't even get to see the message there. Actually, we should have armed those. Get rid of that. Get rid of you.
500.
Bit high. On path. Yeah, fast trigger. That is on the ball today.
$100. 50, 40, 30, 20, 10.
There we go. Made the exit without an overshoot. I should have started the APU earlier, but I didn't want to stop there. That's what you get for using a push button for break-in. Alrighty, now I'll do this, that, and the other. Co-pilot here. APU is still not available. But then retract the flaps and all that good stuff. And the GA parking area is right over there. And just put it right in front of their front door. Oh, that BMW's got to be there for us. He's waiting for us. We don't need both packs, and pedos can come off. Alrighty, that's stopped, and we take the gens off bus, and then sweet. Okay, and beacon off, and there we go. Parked at the. BMW drove off. Well, screw you, sir. Well, anyway, that's about all there is to it. Now it's going to beep a little bit about the hydraulic stuff. And actually depressurize them all. Turn off the nose wheel steering already. And all that is left is pretty much just, you know, pass around the champagne and stuff. Got a nice total for our trip. Fuel used. Total, true airspeed, ground speed, effective air and ground distance traveled based on air and ground speeds. And can you pressurize the cabin with the APU right now? Yes, I can. What would you like to test? Hey, Jonesy. Yes, and you can get at these flight logs, by the way, while I still have your attention. You don't have to worry about losing them because I went ahead and made them available to you. NVRAM, and there they are. So flight log, which one? This one, probably the latest one. Or hang on, what is that? Which one's the latest one? Give me the date modified, you idiot. Really, the most useless pieces of information. June 10th, so it'll be today. I think this is the one that we want. Right? Yes, I think. Yeah, there we go. Oh, I'm an idiot. Go to the marathon, man. You go using your flight log? No. No, I'm an idiot. This is... Each of the flight management computers has its own flight log, so that's what I was looking for. So it's basically just a sequential list that gets appended to. So this is the flight that I just did. So you got your distances and all that good stuff. So this is basically matched up to this. 1 hour 13, 1 hour 13. Fuel takeoff, fuel landing, and it gives you a bunch of other information if it gets that in the FMC. Good stuff. So, hey Jonesy, what would you like to see about the pressurized cabin? Yes, you can. All you gotta do is you gotta switch this thing over to manual control. And yeah, you can pressurize the cabin if you want. Right now we're in manual pressurization control. And just hold the stupid X-plane control thing in the appropriate direction. Now it's right now not doing seemingly anything because of the fact that the valves are still fully open. But if I go to here, pressurization control. And it's the other night with an A320 was just curious to whatever you do. Yeah, you switch it over to manual pressurization control and hold the altitude control knob, and you'll notice that the valves here right now they're open to, you know, whatever that kind of a degree is. If I hold the switch down, you'll see that they're going to start closing up. I'm going to increase the cabin rate so it goes a lot faster. And you might be able to see that the valves are slowly, well, first of all, it's going to be the lower one. called the primary valve, or the master valve, and then the slave valve, the upper one, is going to come down. It's going to come down a little faster because it's less on less spring pressure, so it's got a less tightly wound spring, so they are effectively in sequence with each other. They don't close and open at the same time. First one opens and closes, and then the other one opens and closes in reverse, obviously. So this guy's closed. You can see already we got a slight rate down, 100 feet a minute. But as soon as the other one starts coming, you're going to see that rate increase. 400, 500 feet, and at this point you would probably reduce the rate down so your ears don't blow. And as soon as we start closing it up a little bit faster, when it gets to fairly closed, it gets a lot more sensitive. So 400, 500 feet a minute, 600. Just trying to keep a constant rate here, so you have to basically sort of play around with the manual rate control knob. But yeah, there we go. Diff pressure 0.2. If I wound this up all the way to go to max rate, you'd see that the rate would shoot up, or well, shoot negative. 3,000 feet a minute. And now we're fairly highly sensitive to, rate modulation at this point. Now at minimum rate, even at the selector, the needle valve set to minimum, we're still going to get about 400 to 500 feet a minute. So there, and at this kind of a differential pressure, it doesn't really take all that much valve movement. You can see it's moving by fractions of a millimeter there. And that's already enough to give you a camera rate of 400 feet a minute. Now if I release it, it'll stop. Basically the valve is going to stabilize at a certain position. Now really what you're doing, by the way, the key here, is you're not controlling the valve. That's kind of the wrong way to think about it. This controls the set altitude, so the target what the pressurization system is aiming for. The valve will modulate itself. Sure to ask, ignoring each 2%. What's your job if you're in the development industry? Well, this is my job, but I'm a software engineer by training. Can't see it any other way. And yeah, this is how you do it. Or if you want to make everybody pissed off, just roll the rate up to max and just rock and roll. But yeah, you can see we've got almost 1 psi of differential pressure already. And in fact, if I turn on the other pack, it'll go even faster. With both packs putting air in. Could probably get it over 4,000 feet a minute. Yeah. And if you want to get everybody pissed off, you don't depressurize gently by pulling it up, and slowly open up the valves. No, you just go ahead and turn on the auto pressure controller. And that will automatically shove the valve fully open. And you're going to get like 20,000 feet a minute as the air rapidly escapes out of there. Yeah, that's it. Anyway, folks, it's way too late. I went for way too long, much longer than I wanted to, but originally, but whatever. We're here. And yeah, green is there. Still got to get obstacles and a couple little bits and bobs here and there, but green is all pretty much done.
Wide slope. Pull up. Wind
Talk
shear.
to you later,
Wind
folks,
shear.
and
Wind shear.
I'll see you on Discord.
Terrain. Pull up.
I'll see you all on Discord. Take care, everybody. Love you all, and cheers.